Hello, hello. I'm watching an ad on my own channel. Gotta get the ad revenue somehow. Just kidding. Okay, GJK and EPA. I took some notes. Not some notes, but a lot of notes. Oh my god, I just got coffee on my camera. There's a little bit of coffee on the desk. The reason why there's a little bit of coffee on the desk is because I froth my coffee in a glass, and then sometimes some of the froth just goes on the side when I'm frothing of the glass, and then I sometimes forget to wipe it off, and then it gets on my desk a little bit. And now I just wiped my phone over it, and so that's not great. We're going to ignore it. Okay, so I figured out the bug last night that I was stuck with. The bug was right here, and I want to talk about it because it's not the first time that I've gotten this exact bug with this exact pattern. It's completely my fault. I see the pattern and then I forget about it every time. But okay, so the pattern is this, right? So we have a few arrays here, a bunch of different arrays, but we have this visible faces array, right? So basically when we're going through all of our all of our current faces for our convex hull. So all of the faces we have so far, we go through them, we check them, dot the normal, and then for the ones that are visible, we push them onto this array. And we push the indices into another array. Important that we push the indices because when we are moving our holes around, we don't actually want to move the holes raw because it's a lot of memory. We instead just want to swap the indices. So our indices are independent of where the holes are actually in the array. So let's say we have a final hole indices array of like 8, 52, 35, all of those different arrays, all those different indices, and then at the end we just fill an array with those indices. So the faces aren't actually the faces. The faces array is all of the faces we have emitted so far. What's up, Frank? So we're just moving the indices around. So when we delete a face, we delete it from the indices. When we add a face, we also add it to the indices. So this is important because when we remove from the whole indices, we have to, of course, shift everything over, right? Because we're removing it from the middle of the array. We want to shift everything over so that we don't have empty spaces, because we delete holes, or we delete faces of these holes that are visible. We delete the visible faces, and so that's what this does. We're deleting the visible faces. However, if you just do this, then you aren't adjusting for the ones that we've deleted so far, which is what I had previously, right? I just totally didn't think about it, just went right past it. This is the one line, 3 characters that causes us a lot of problems, because if we look at what this is doing, we are removing from this index into this array, we are removing that, shifting everything over, and so the next index that happens after it also needs to be shifted over, because we just shifted everything over. So once we delete one, we need to shift over one, because everything is, I'm sorry, I just hit the mic, everything is back 1, right? And then once we remove 2, everything is now offset by 2. So I didn't notice that, well, I know the pattern. In fact, you can go back into the streams and find at least 2 streams off the top of my head where I was also stuck on that same exact pattern, and it's caused me a lot of grief in the past. And so the fact that I still lack the ability to connect the fucking dots is startling, to be honest. So I feel pretty bad about that. That I was like stuck on it for like hours yesterday. I was like trying to figure out, because I was sure it was the algorithm that was the problem, but it wasn't the algorithm that was the problem. It was just simply my logic. So my specs are that. Is 3D collision detection complicated? It is. It is pretty complicated. It's why I basically, in my other engines, I've faked it. I've done some faking it, but this time I'm trying to do it the correct way, which is what you're seeing right now is you see the shape underneath is the just the raw mesh, right? And then over it, all the white lines are all of our holes, all of our faces of our hole that we've now emitted. And if we want to see the difference of what the bug looks like without this, then I can show that off. What we saw yesterday was this. And so you can see, obviously, the white just disappears on this side because we're deleting faces that, obviously. So very small amount of code, big, massive fucking impact. Okay, so a few things here. So I've written notes up here about everything that we're going to have to do today. So all of these notes I've taken. This is what we did yesterday. So this is what we did yesterday was the hard part. Okay, so that's definitely the hard part, because EPA, which is what we're going to end with today, is pretty much just, it's going to reuse the code from incremental hole. Pretty much, we're going to make an abstraction that just does both. I think that it'll be possible to do that, because literally all I have to do is this is exactly what we do in incremental hole. It's just we have to keep track of a distance from our new holes. Thoughts on Rust? I don't really have thoughts on Rust. I did a couple of projects in Rust, and I did the Rust book a long time ago. I think it's similar with all the new languages. I don't see like a big point in Rust, to be honest, in replacing C++. The compilers are just, not old enough. Like the good thing about writing C or C++ is that the compilers are, have been, iterated on to the point where they're so good that you don't even have to write good code. You know what I mean? So that's the problem I have with Rust, is that I just don't trust the Rust compiler. That's the problem. It's just too young, That's the problem with Rust. Other than that, it just doesn't really, there's a few things that are neat about it, for sure. But I also don't like how you kind of have to prove to the language that you know what you're doing. Like how you, for example, write arrays, the syntax itself. It's like, I know what an array is under the hood. I shouldn't have to prove to you with ampersands that I know how arrays work, So it's also like just annoying to write Rust just on its own. But I don't hate it particularly, It's definitely not, as egregious as like other newer languages like Nim and Zig and Odin and all that shit. I just don't. That shit kind of doesn't have any purpose to me. I think I'm going to stain these pants. I think that's going to stain these pants. Oh well. Okay. Moving forward with my life. So a few things that I want to get done before we move forward is how messy this is. We have a lot of vectors here. So first and foremost, I don't think that we should have these triangles as a thing. I think that we should only be working with indices pretty much, because what we want to have at the end, so we have these mesh vertices, right? What I kind of want is every whole face to simply not have vec3s on it like a triangle, but instead just be references into the mesh vertices array. That's all I want. That's all I want in life. And also this mesh vertices thing that we get from decompose mesh, which just deduplicates stuff. We don't want it in mesh vertices. We want a separate array, because mesh vertices should be the vertices we get from the actual file. I think that we want a separate thing just for our whole vertices that are our deduplicated, decomposed vertices. And so I'll put this in convex hull. Oh, we do have points in here. Okay, so let's just add on to the whole points rather than the mesh points. What resources did I use for implementing 3D collision detection? I took notes on a bunch of videos. So all of this, the notes that I've done here, are all from videos. And after I implement these and I've verified that it's correct, I'm going to post the notes in the Discord as well as the videos I referenced. And some other code, yeah. And some other people's code. Alright, I need to make sure that it doesn't drip on the pants again. Okay. So when we decompose the mesh, what this is doing is it's putting our points... Where is this? Yeah, we should probably... Looks complex. It is sort of complex. But that's alright. So we are going to the mesh vertices thing. For now, let's hard code it to just go to one hole. To one hole. Okay, so that's what we're gonna do. Do I initialize the... No, I don't. Okay, so let's just set this to go, instead of to mesh vertices, let's set this to go to mesh hole, which is right, later we're gonna have multiple holes, but for simplicity's sake, we're just gonna have this now. So we're always going to be going into hole points, and we want to therefore cast hole dot points here. And in fact, before we go too far, we want to call this vertices. And we don't need a vertex count because that's simple. It's just going to be vertices, and then we'll go hole.vertices.count because we have a count inside of the vector type. Okay, very simple. So we're just renaming here. Okay. So all we're doing here is we are adding onto our whole vertices when we decompose, and later we're gonna do more stuff with mesh decomposition, but for now that's all it is. It's just deduplicating points and then putting it onto the whole vertex array. So instead of using mesh vertices, what we will use is mesh.hole.vertices, and this is what our whole faces are going to reference into. So our mesh hole faces are either going to be the type of triangle, or we just won't use the triangle at all, the triangle struct at all, because the triangle struct has points, and each point has position, normal, color, and UV, which should be per vertex data already. So how deep do we want to go with this? Yeah, let's make a new... Yeah, let's make a new struct. Call them mesh face. Thought about adding multiplayer to my space sim. I think that would be cool. I kind of did have that idea in the beginning where it was like, oh man, like wouldn't this be cool if there was like some level of that? That would be kind of sick. I don't know how. I've never implemented multiplayer in my life, and I don't really know how to do like, you know, whatever the hooks and stuff like that. So maybe that would be an interesting project for me. But the space sim is kind of just in kind of limbo. I don't really know how to finish it because it kind of outgrew my limited hardware constraints. And so it's kind of at the point where it's hard to move on, to be honest. But yeah, we do need a normal, yeah. So that's all. So instead of points, we're just gonna have indices into the points, indices into whole vertices. Probably complicate my physics and collision detection code. Actually, not really, because, well, depending on if players could collide with one another, yeah. But the space sim, yeah, I mean, syncing everything would be pretty hard. Would be pretty damn hard. The when you're on a planet, the logic would be fine, right? Because that's just the density field, you know? So none of that actually has to be synced because it's literally just static data. It's generated in real time, but it's, you know, completely deterministic. The problem would be, obviously, the particles of the bodies themselves would be... I have no clue how you would do that in multiplayer. I feel like you probably would have to have some sort of server doing that, and you would just be streaming the data, I think. But that's a lot of data to stream because, you know, that's a lot of fucking planets. You know. Okay, so this mesh face is what's going to go into faces, and that's like a much slimmer struct than doing the points, which is what we want. So every time we cast vec, we need to do mesh face. So now instead of indices.pause, we will be going indices and then going into our points. Yeah. It looks kind of complicated, but it's alright. Yo, what's up, Icy Bear Raw? How are you? Okay, so visible face is another one that we want to change to a mesh face. Right now what I'm doing is I'm just slimming down the structs because our triangles have had a lot of per vertex data inside of them that was getting copied. So what I'm going through now and just making sure that we use a much slimmer struct, which is this mesh face, which is just indices into the array. You're fine? I'm alright. I did have a bad bug yesterday that took a long time to figure out, but that's alright. I think that I don't think that you ever get to a point of programming where you just don't write bugs. I don't know. At least that's the way I feel with it. It's kind of impossible to just never write bugs. Especially when things are complicated, you know. So the good thing about this mesh face is now we aren't copying a ton of data. We're literally just copying 3 indices and one vec3, when before we were copying like 12 vec3s. So that's a lot better. Also, something that I just realized, us pushing this onto visible faces, we don't even need to push it onto visible faces because we have visible faces indices, which just goes back into the whole indices. So instead of V faces, we could simply just go back into faces. Especially logic bugs. Yeah, like that shifting, like I don't write like, you know, memory leaks or anything. Like that stuff is like, you kind of learn it once and then you kind of understand how to do like the structure of things. But when it comes down to like, you know, just not like taking account everything that's happening like math wise, then you fuck up, you know. And those are also the bugs that like debuggers can't solve, you know. It's that, yeah, it's like hard to track them down. So we are going into visible faces indices. That's what we want to go into. So this is int. Yeah, so we'll just move this up there. Yeah, okay. Just making sure I don't fuck this up because this is kind of complicated. My own like vector implementation here is like a lot of boilerplate. So we want to get the face. So instead of going into visible faces, we're going to go into faces, but we're going to index into it by visible indices F. And that should work. And now we need this to take in a mesh face. Unfortunately, what this requires us to do is we need to take in our actual convex hull. Let's just take in the hull, because this will give us the points. Do we need a cast vec? I think we do. The vertices that I push are vec3. Whole vertices, and then yeah, cast it as vec3. So that's how we get our points, and now we just want to index into our points based on what is on the face. Hopefully I'm thinking about this correct, but that's how it makes sense in my mind. You just use the face indices. Wait, no, you need the oh no, you have the face. Okay, yeah. Yeah. This is correct. It is it is complicated. I'm not gonna lie. It is a bit complicated. Do we have the whole? Okay, that's fine. Okay, simple stuff. Okay, so now we're removing visible indices. This is still correct. This is the same thing as we had before. Nothing changes here. When we add horizon faces, we're adding P, which is the vec3, and we're adding faces. But now the faces are obviously going to have to be mesh face. And now instead of the points, hold on. The problem with edge E is that edge E obviously isn't indices. So this doesn't really translate because these are just points. These are just raw points and we need indices. So edge actually needs to be 2 indices rather than 2 points. And we need to pass the indices around. Let's see if there's an easy way to do that. Do I ever use dynamic arrays? Yeah, all of this is, well, I'd avoid vectors when possible, but these are a lot of vectors because what we're doing here is a lot of reallocating just because it's necessary, because we're discovering things as we go along, right? So every time I have this init vector thing, I pass in a certain size, right? And it stays on the vector struct so that every time I add on to the vector, it knows how much it needs to grow, right? So when I do cast vector, all this is doing is it's casting the buffer to a certain type. So that's how the vector implementation goes. Okay, so the problem with horizon edges is that it either needs to be indices or we just have another array. And I think we just want to have one thing. So I'm just going to make a new struct once again called horizon edge. Which, this seems stupid now that I'm doing it. Is this stupid? How stupid is this? Would I rather have a struct or just 2 wins? How would I allocate that? Can I do size of int 2? And then I think I would rather have it like this. Yeah, it might get messy the other way. Just the way that the vector works out, in my mind, I'd rather just keep it stupid. Yeah, it is generic, yeah. In my first game engine, I didn't do, I think I had one generic vector thing, but I tried to avoid it as much as possible because, as you can see here, it gets pretty complicated because we have to always keep track of what we are casting the void pointers to, right? And so if we forget what type we're, casting to, it can get really, really complicated. So yeah. So we're going to use horizon edge this time. And now we have to go through and figure this out. So we're still passing horizon edges here. We're just going to cast this to horizon edge. And so horizon edge C. Oh, right. So instead of actually going into points, we're just going to take the indices. But we do also need the points because of that. Let's just go back to this. So an easy way to do this. It's not seeming that there is, but we'll find a way. There we go. Okay. We need the points, obviously, because we need to compare them. Okay, so now we will use A and B directly for the comparisons while we only store the other stuff. So what is this used for? Oh. So we actually need to do that because now we're checking against our already stored horizon edges. Let's make sure that I'm doing this correctly. We haven't even started coding what we were supposed to today. This is that's never a good sign. We're already behind schedule because I decided to refactor this to be more efficient. Quite unfortunate. But this is going to pay off dividends later, for sure. Okay. So now our horizon edges are the correct type. Okay, so here it's going to get mad at us. But now instead of getting an edge, we will take in a horizon edge. And we will take in the convex hole. We'll try and clean that up later, but the idea is that you take the whole vertices let's just keep it points because that's what we call it everywhere else. We're going to cast vec for the whole vertices, and we will cast it to vec3. And now this e.a b0 will just simply index into points like we discussed earlier, these are just, the edges are now vertices, or now indices. And so now we have all of our points. Unfortunately, this P is also going to have to be P IDX, which is just a index into the points array. And so now, oh wait, no, I don't need the points array. I don't need the points array because these are just, we do, but we are just going to assign to the faces, we are just going to assign indices. We're just going to assign PIDX E.AB0, E.AB1. And then we just swap when the normal is wrong. Okay, so basically this is equivalent to what we had before. Well, it's not basically, it is just equivalent to what we had before. It's just, you know, better. So compute triangle normal is going to be a problem because we did it with a try. I'm just going to rename this to mesh face normal. Oh, but then we can't. Oh. I just prefer to, I don't know, to be simple with these things, but I wish that you could do this and then, you know, that would be nice. There is a way you can do this with macros, but I don't know how to do it. I don't want to get rid of compute triangle normal because that's probably used somewhere else with that type. So for now, what we're going to do is we're just going to call this compute try normal, and it's going to take in 3 vec3s. Whoops. Okay. Because we have compute triangle normal all there, we are going to have to also change those, but the whole point of, you know, not having it 3 vec3s before is because I don't like having a lot of arguments in my functions. But now we swap B and A, and so that this becomes our ordering for our normal. And that's cool. Okay. I don't think we have P IDX, we have the whole vertices, that is important, and we have the horizon edge. So let's just go down and verify that. We want to cast this to horizon edge. Nice. Okay. Horizon edge again. And we need to be passing the hole. So we're just going to pass mesh hole. And P is going to now be the IDX of P. Into the vertices, which is simply I. Okay, that's cool. So we reached the end of the function, and so you may think that we're done, but we are not done, because of this needs to be mesh face, and then this also needs to be mesh face. We also have to change the initialization for the tetrahedron to mesh face. Okay. Let's just see our other casts here and make sure that they're fine. They look actually completely fine. The next thing that I can think of is going to be the setup initial hole points, which needs to be changed. Obviously. The good thing is that we don't actually, for our initial stuff here, we don't have to cast anything. We just want to make sure when we init vector, we obviously init vector to mesh face. And now we need to do the same work that we did in the horizon faces reconstruction here. Okay. So obviously we're going based on indices now. So it's important for us to get moving, not moving indices, but indices that tell us what's going on here. We're just going to do this. Maybe later it's more efficient to do it in an array. I'm just going to do this. All we're doing is keeping track of the indices as we go along and compute our shape. Our 3D object that we kick off our incremental hole algorithm from. I think that should be fine. And so now everywhere we have A, B, and C, we simply need to replace it with AIDX, etc. Faces.indices 0, 1, 2, right? And we will make it AIDX, etc. Excellent, excellent stuff. Of course, the compute try normal is going to have to change because now we need to actually get the points, right? So in this case, it's going to be A, B, and C. And then once we swap B and A, it's going to be B, A, and then C. And so the swap, like we said earlier, is once again we're just going to swap that like that. Okay, now we have to do the same thing for everything, which is slightly irritating. Ever so slightly irritating. If this doesn't work after all this and I miss something, that's not gonna be good. The recomputing printout there is just so that we know if we ever get an impossible combination. It's just a debug thing. Luckily, I think that this is the end of the refactor after I get these couple of lines done. If I did it correctly. What was this, A and D? Okay. A, B, and D. Okay, I think we're done. Hopefully. We're not going to really know until we compile it and then see what's up. Shit. Oh, man. Oh, okay. Well, oh no. On the rendering side, we need a change because this is based on this. We obviously need to go by mesh face now. And instead of also we need to index into the points. Whole vertices vec3, and so this is going to be a mesh face, and so instead of try points, it's going to be try indices into the points. All right, let's try that. Fuck. All right, let's go and try just the initial tetrahedron. Oh, whoops. Okay, well that doesn't work. Okay. As long as I know that that doesn't work. Mesh tries to triangle. That should be fine. That should be fine. It's probably in here that the problem is. Pick lowest point mesh. It goes based on mesh vertices. So that should be fine. Oh, I never assigned the normal. But that shouldn't matter because we aren't even using the normals yet. It's still a bug, but oh, you know, it doesn't even get here. It doesn't even get there. Oh, it's in pick lowest point. Point I dot y less than lowest. And why is that? Oh. Uh-huh. Vert J. Okay, so this Oh no, it's pick lowest point. That's the problem. Oh, I'm not going by mesh hole dot vertices. Oh, whoops! Can you stop? And why? Why is it now still set up initial hold points vec3a equals points lowest index? Oh. Whoops. Yeah, it is kind of confusing, the naming convention. I will admit. Okay, why are we not seeing the why don't we see the tetrahedron or what have you? Can we see? Wait, we don't see anything. Print out. From setup initial hold points. It should print out center and ABC. And it doesn't. Which means that this has to be failing. I want to see which point it fails on. Because one of these has to be failing. Let's do breakpoints. B best is less than or equal to EPS. Let's print out the Okay, that's the tetrahedron. Am I saying that correctly? Or is it? Yeah, it is. I have no clue if I'm saying it correctly. Apologies if I am. Alright, let's see if we can make it. No, it's the same thing. Did I compile? I did. Okay. Faces count 4, it said. Okay. Oh. We're going off of the wrong count there again. We're likely going off of the wrong count somewhere else as well. Or something. No, that is whole vertices. I forgot to do that. Okay. I need to just know if we're processing. God, I mean, I had this working and then I decided to refactor it and now it's kaput. So we do process points. That is whole vertices. The face that I'm passing it, face is visible indices F. Isn't that whole indices? It is. I'm gonna guess that we just never get into there, obviously. But we never go into here either. Right? Yeah, we never go into there either. So that means that we never get any horizon edges. Do we get visible faces? We don't. Points face indices 0. Face normal. So this we never get here. We do. We do. We do. We do. Oh. That's why. Because we got rid of the other array, but then we didn't do anything with it. But then why is this still not working? We still don't get into here. Oh. Because of this. Yeah, we have to get rid of that array. Okay, there we go. We fix it. We fix it, we fix it, we fix it. Okay, nice. We can get rid of all the debug printouts now. Okay. Back to working. Back to a working state. Yeah, looks good. Okay, so moving forward here. This is processing. Moving forward here, I want to copy this file now, just because it's in a working state and I feel like I'm about to fuck with it. Okay, so okay, so we're gonna move on to GJK and EPA in a second here. A few things I want to do is I want to move some of these things to utilities just to clean stuff up here. Honestly, we should be inlining this, if I'm being honest, I believe. Alright, so let's just inline a couple of these things because it's better. Because we've cluttered this file well enough. This file is at the point of being quite ridiculous. So I'm just gonna clean it up before we move on. Something else I want to clean up is I want to get rid of that visible faces mesh face array. Because it isn't necessary. The rest of this is quite necessary. The decompose thing will work on later, but the rest of this is quite necessary. Add horizon hold to, let's just put, obviously print triangle can be just inlined in utilities. obviously. Remove int from vec. This is really only a helper for this very specific thing. In fact, what we probably should do is make this a macro, but I don't know how to macro it. Oh my fucking god, man. I don't know how to macro it because it's kind of hard. And it would take in a v. Let's just call it vec and index. Can I call this macro from the macro? Is it supposed to be that way? No, right? Hey, what's up, Code Rep John? How are you? What am I making? I'm making like a rendering engine. So right now we've got the ability to just load in meshes, and right now I'm doing collision. So that's I have a basically a convex hole finder that finds the hole, and so I'm just kind of working on that. I was trying to make this macro to do this, but I've never done this before. I don't know if you're allowed to just oh wait, no. Is this allowed? I've never made a macro like this. You're gonna do that? Yeah. It's a lot of fun. It's a lot of fun. Does that work? We can give it a shot. It needs to take in a pointer to a vector. Whole indices, index visible indices f minus f, the type of int. Cannot take the address of an R value of type size t. What does that mean? Add whole indices is a vector. Yeah, it is. Maybe I can't do this. Visible indices is an integer. If I do this, does it go away? No. You finished Kill Bill? Yeah, how did you like it? Did I mean to use... so it's mad at this. It's mad at this. Oh, because this is a size T, I have to cast it to int. It's pretty badass. I watched the whole bloody affair. Why did you capitalize that? Why did you capitalize that? Why is it vec dot count? Why is it vec dot count? Is that just how it is in macros? You have to use dot? Because the whole bloody affair is one movie where this... Oh, I see. Yeah, I don't remember if I saw the whole thing when I was a kid. I think it was... I enjoyed it, though. I did enjoy it. We could just shrink the count after. If we really... You know, we could shrink the count after. Oh yeah, we didn't even check. Can I do this? Oh, I can. Oh, that's neat. Yeah, apparently I can't decrease the count, which is weird. Oh shit. I figured it out. So then you could do like that. Okay. Okay, we're macroing. Okay, let's see if it compiles. Did I cut my hair? I did not. If I cut my hair, then I'm going fully bald again. I mean, not bald, but buzz cut again. But it's just a pain in the ass. And then it gets to be more of a pain in the ass when you get later in, you know, in the stages of having hair. Like right now, it's, if I go and cut it, it's going to be like, you know, a long affair. And I don't think like I'm mentally ready for that shit. Okay, so we can get rid of this. This is a beautiful macro that I made. A beautiful dustmite macro. Love it. I have 6, 7 followers on Twitter. I don't believe you. I do not believe you. Alright, this is as clean as it's gonna get. I mean, it is a large file. That's kind of the problem with it, is that it's so large. I should probably split it up into multiple files, to be honest. But whatever. Okay, I mean, moving on. So we have our check general. Sure. We'll see the 6, 7, and then we'll laugh. All right, 6, 7. Oh yeah, I see 6, 7. Nice. Good 6, 7. Good stuff. All right, so our incremental hole is finished. And now we move on to GJK. So I took some notes on GJK earlier. In fact, we wrote some of the code, like find next simplex point, except we didn't really, finish it. We didn't really finish it, but that's gonna go here. Yeah. So GJK is gonna take in a convex hole A and a convex hole B, and we will find the intersection with them. For clarity, the origin is 0, 0, 0. So vec3 O equals 0, 0, 0. Just so that we can be extra clear with what the fuck is happening. Okay, so we need to pick a random direction. For our first one. Newest point always becomes A. Right, our holes already have a centroid, so we can check the phase normals against that. Newest point always becomes A. Right, yeah, got it. So we pick a random direction, and then we get the support diff in that direction. So this is going to be a while loop. We're just going to have a bool searching. So while searching, we will loop. Okay. So the first thing is this support function, which I believe is this. The support function Did I write the support function down? I guess not. Okay, so let's look at what I wrote down for support diff. Okay, so we take in our two holes, we call support, and we subtract that from that support with the scale dir -1. All right, so we're just going to assume that that's correct. Or watch each of his films in one sitting. That's a lot. You like Tarantino that much? That's crazy. Okay, so this is the support function. We go through the whole vertices, and we find the best one in that direction. So we'll just leave this as this, we need to get a cast vec here for vec3 pointer verts equals cast vec for h vertices with the type of vec3. And we will iterate like that. Now I wonder if we want to take the indices to the support points or the actual support points. I think we actually, believe it or not, we actually want the indices to the support points because of EPA afterwards. We need the indices of these points so that we know which ones to skip. You love Tarantino? He might have a foot fetish, but I forgive him. Yeah. I'm not like the most insane super fan of all time. But I mean, he's a cultural icon in America, for sure. Okay, so this is going to be equals I, and we will return best IDX now. Okay, returning best IDX, and then we will need to take both of these and then subtract the points that we find. Oh, the problem with this is that the support points are within are not hold dependent. Oh. Okay, never mind. We're not gonna fucking do that. What OS will still be relevant in 10 decades from now? 10 decades? 10 is a century. Bro, that's a lot of time. Probably some dumb bullshit server bullshit. Like fucking FreeBSD or whatever the fuck. I don't know. That's at least what I'm thinking. FreeBSD. Yeah, that's what I said. Oh, you think that was a valid jinx? You can't type a jinx in the chat. Like, who knows what the stream delay is? Our dir is going to start straight up. I don't know. Just for fucking shits and giggles. So if the dot between the support and dir is less than or equal to 0, break. We will also have a bool collision equals false, and then we will break. So this is at the end. We'll say if collision FreeBSD is a good OS. It's just that Bluetooth on it sucks. Really? Is that what it is? It's Bluetooth that sucks? That's crazy. Add support to simplex. Okay, so this is where we start getting complicated. So we are going to have a simplex S. Okay. We're going to set it to 0. and then our s dot points, s dot count plus plus equals support. Except we can't do that. We need to wait, why do I have a different fucking thing here? Let's not worry about that. Let's not worry about that. We need to make a new function. Add point to simplex. It's raining here. Well, that's nice. I wish it was raining here. It's just fucking really bright outside. Apparently, my my neighbor's dog ran away because of the fireworks, which is sad. Very sad. Let's ban the 4th. I agree. So this is too many points. We should never hit this, but okay, so we're just gonna shift everything over. Actually, yeah, let's go by count. Okay. Okay, now we have a function that shifts everything over in the simplex. The newest point always has to be in position A, which is what so this is what this function does, right? So once we find the support point, we just want to add point to simplex with that support point. It's that simple. At least I think so. Okay, so now we change the direction, right? I hit 6-7 followers. That's crazy. That is crazy. So now is where we call find next simplex point, I believe. I don't think we want mesh, because we're searching both. We're not, this isn't a find next simplex point. It's actually find next direction. And it just takes in the simplex and it just takes in the simplex. Everything we do is just with the points. Because our dir is just we always go in that direction and then find the point. Okay. So let's just get rid of this because this is obviously fucking bullshit. Okay, so we're just going to return a vec3. Helix is what happens when you take peak, but take out a bit of peak, but add a lot more peak, but then remove all the config. Yeah, I don't really like configuring shit. I find it like kind of a waste of my time, to be honest. I'd rather just write code. So I like how Helix, I don't have to fucking configure anything and I can just code. Never used NixOS? Yeah, I gathered that much. That's why I honestly, like, I was fine with, like, more boring Linux distributions before I went to Arch because, like, honestly, I just like shit that just works. I don't know. Okay. So now case 2 is where it starts getting fucked. Case 2 is where we have to open up the split and then... Okay. So case 2, because the origin can never be beyond B, we just searched in that direction. We only check... Well, didn't we just search... Oh no, we searched in negative A. And then we got B? No, we got A. We put everything in A. We only check if the origin is behind A. Okay. Install calculate Linux. I'm gonna make a Helix plugin for terminal support like term and vim. Oh, that's... I mean... well... You might find it hard to do that. Okay. And then we... If... If this is less than or equal to 0, discard B and dir becomes negative A. Discard B, so that means that S count minus minus you're using Steelix. Yeah, I still have no clue what that is. Like, I looked it up, but then I didn't really find anything substantial about what it actually is. Else, the dir is going to equal some cross multiplies. It's an AB, AO, AB again. So basically what we're doing here is we are finding a new direction based on our current things, right? If we have 2, we want to go perpendicular out. Otherwise, yeah. I'm worried that the dir may be in the wrong direction. But we won't worry about it. It's Helix, but they added plugin support. Yeah, I got that much about it, but I don't really trust Helix, Helix and plugins. The whole point about Helix is that there is no plugins. That's the best thing about Helix. So I don't understand like what the you get what I'm saying. You get what I'm putting down. Or is there no one in chat? I don't know. It kind of is like this, right? Like I'll come back for like a couple of days and then everybody disappears. I mean, that's fine, I guess. If I wasn't live, then I'd just be doing the same thing offline, right? So I'm not like, it's not like I care that much. But it's kind of like a snowball effect, right? Like people don't like to be here when there's no one here. It's kind of awkward, I guess, but whatever. Cross normal with 2 edges. Cannot lie within BC. The fuck was I smoking? Okay. I don't know. I wrote these notes and I guess I didn't read them until now. I hope that. I also have no clue really how I'm going to test the collision. I haven't really thought about that yet. Rewrite it in Java. I'm all good. I'm absolutely good. Fuck. Okay, lock the fuck in. I'm not locked in. I'm really not. Okay, so we need to go AB and the normal. And then AC perpendicular is the normal and AC. Now I'm kind of worried that we're not orientated correctly. I'm very worried, but okay. So now we take the dot product with AO. Take dot product with AO. Wait, take the dot product of what with AO? Both of them? I think you need both. Oh yeah, you do. You do both. Yeah, you do both. Once again, A0 is this. So we dot ABP with AO, and this will find if we are outside of ABP. And if ABD is greater than 0, then throw opposite point away. And then what does my direction become, though? Like, obviously here we would throw C away. That's the whole point, right? And so we would remove C, which simply would be S count minus minus S. S count minus minus break. But what is our direction then? Is our direction AO or is our direction ABD? Can you rank desktop environments and window managers? I haven't used a ton of desktop environments, I guess. Can I count Windows XP? I think KDE Plasma is shit, and GNOME is shit. Like, okay, so here's a good one. So you're a little fellow, and you're just like, I want to do Linux, and then you just get a bloated thing that's just the exact same thing as Windows, just Linux, and you think you're special. I'm sorry, but that defeats the whole fucking purpose. You get a window manager and you just live your life. It's not that. I'm sorry. Otherwise, just use Windows at that point. I don't know. That's my take. Sorry if that's controversial. See, over here we do this. And then set dir to AO. Are you proud that I don't use a desktop environment? I don't know if I'm proud, like you don't have to worry about, making me proud. I'm glad you don't, because that's cool. But it's not like one of these things where I'm like, where I like judge people about it. Oh gosh. Is it really AO? We may have to watch a video. Oh, also this isn't S. Oh, this is a B. Oh yeah, so this is going to be remove B. She's gonna do the same thing as this. Just the opposite. Lisp based languages like Emacs Lisp, I think it's cool. It's cooler than other things that are like in the similar vein of like Lua and shit, right? So I think it's pretty neat. This is this supposed to be S count -1? Yeah, I think so. What editors did I use before Helix? I used I started off when I started programming in school. I used NetBeans, which is pretty underrated. And then I used VS Code at some point. I also used Eclipse. I used Visual Studio. But after VS Code was really shit. And then as soon as I like discovered other things after VS Code, it was much better. Like I also used NeoVim for a bit, like when I was a teenager, and I thought that I was like a hacker or whatever. Like I would sit in cafes when I was like 16 and just like, code away on NeoVim and with a coffee and all that shit. And then eventually, yeah. Then after VS Code, I like tried to shop around. I tried this shit Z, all this other shit, and then I found Helix, and then I just never looked back. So there you go. What do I think of Zed? Complete dog shit. Like, it's actually like almost funny to me how bad it is. It's actually hilarious that people actually use that. I got a guy that came in here that was talking about it. Like, dude, how ill are you? That shit sucks. That shit is like actually funny. Just VS Code, but without Electron. It didn't feel like it was without Electron. It ran like shit. In fact, like it was actually like funny how bad it ran. Like I thought that it was like a joke. Because it was just like the slowest editor I've ever used. And they have this shitty like 60 FPS scrolling thing that like just breaks because they have like internal fucking like VSync going on, so it just like looks like shit when you're like scrolling, and half the time it's like smooth scrolling, and then the other half of the time it's just like it's just looks like, you know, awful. It's complete shit. It's like funny to me. It's just crazy. What do I think of people that use smooth scroll? I can't imagine you writing like people like actually writing serious code and using smooth scroll. Or honestly, I don't mean to be a dick, but the fucking cursor jumping around and shit, like you're not serious. Like you're not. Whatever, bro. That's just my opinion. Right, I have to do this for all the faces. Can I actually loop this? I probably can. Hold on, let me think about this. ABC, BCD. Okay, so here's the thing. We can do this. We just have to have an array of things here. What do you mean cursor? I mean like the shit where like when you jump around it like goes boop 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 boop. You like it's just like how to make Helix cursor blink. That's also the downside with Helix. I love cursor blink, but they don't have it. They literally don't have it. So it fucking sucks. Something about it not working with multiple cursors in the terminal, and so they refuse to add it. There's an issue on it on GitHub, so it's not. They know about it. BDC DAC. And then what's the final one? I forget. ABD. Okay, so that array is going to be what we iterate. Okay, so we need to cross B minus A with C minus A for each one. So B would be array I B. And then we index into hold on a second. No, yeah, we're fine. You just go S points, and then this is the index. and then we go A. Okay, so now we have the normal, and so if the dot of that normal with as the blue check mark, that's funny. Yeah, I don't understand Twitter. Like, why would you use Twitter? Like, I get maybe if like you're forced to for a job, but direction equals the normal of the remaining points. Discard other point. Discard other point. How do I discard the other point? Let's just have another array that has it. Yeah, it's way simpler. It's way simpler to do this. Remove point from simplex. We are removing other points I. They're paying $5 a month. Is that actually you pay for the blue check mark? I guess they're rich. Dir equals the normal of the remaining points. Isn't that the normal that we just calculated? Right? You either get it gifted by Elon or you pay a subscription. Yeah, that's crazy. That is crazy. If dir is the sentinel value, then we have a collision. Okay. Why do I feel like we're gonna get a infinite loop here? Let's just do a safety. Okay. Now the tricky thing is I don't have a second hole to test against it. I don't. So how are we gonna test it? Okay, each hole also needs an offset. I didn't consider that because the holes, the points. How do I deal with How do I deal with an offset for each one? Ah, shit. When I get the support diff, and I get the support, I need to pass in an offset. Fuck. Based on where the hole currently is. Yeah. Do I want to keep that on the hole itself or the mesh? I think the mesh, and then you pass it in to this function. Okay. So that's going to be the offset. So when we call it, we need to pass that in support diff. So when we call GJK, we need to have two offsets, one for A hole and one for B hole, which will be just stored on the mesh. Eventually that'll be like a matrix, right? A model matrix thing. For now, I'm just literally going to have a vec3 pause. Okay. How are we gonna do this? Remember when you named the stream Space Game and you boiled all the water? You banned one guy because he was getting on my nerves? Yeah, I do remember banning that one guy. That's a cherished memory of mine, actually. Very cherished. I think it's time to load in two meshes. I think it's time to load in 2 meshes. What did he even do? I don't remember. He was just probably saying some shit about, like, I don't remember. He was just being fucking annoying. He was saying something, I forgot. He was like, don't you want to do this? Yeah, it was the AI guy. It was the AI guy. Yeah, that's what it was. So we can load it twice. And then make a function that just adds a mesh to the buffer. And that's going to take in a mesh and a GLUint. And so it's just going to add triangles to the buffer. And we'll just move this into there so that we can call it twice. So we'll just take in this here, M. And we'll just go through the tries and add it to the VBO. Yeah, the tricky thing is that I want to add it to the VBO rather than... Oh, this is going to get messy. Ah, fuck. Yeah, fuck it, I'm hard coding this. Sorry guys, I apologize, but I'm hard coding this for now just to test this thing because I don't want to fucking do this anymore. This is gonna be main vertex times times 2. God, I should do a model matrix. Okay. Here's what we're gonna do. Here's what we're gonna do. First of all, when we mesh and we set current mesh and we init vector, let's make sure that we set... Is that legal? Just mem set it to 0. I want to make sure that the position is at 0. And then once we get into like our hard-coded main here, oh fuck. Dude, I have mesh 2 open. How many XDs have you hit throughout your Helix journey? Probably a lot, to be honest. Probably a fucking shit ton, to be honest. We're going to put it at 10. And we're just going to add M pause to it. Okay. Now if I call this, we should see two versions of the mesh far apart. Uh-huh. What are we coding? Is this still the Space Sim? No, this is a different project actually. Oh, I didn't do this, so it was the same. It was the same one. What's the difference between space and E and space F? Space E? What is space E? Oh, interesting. I never use space E. Space E doesn't go recursive in your folders, so this shows everything within the folders, and this shows just everything without going recursive. So that's neat. Oh, hold on. I never actually set this to go to the next. Oh, I'm too lazy to do the math. Fucking do it for me. I'm just too lazy. I can't be fucked. Fucking bothered. Bro, where the fuck is this thing? Do we just not have a second mesh? Do we not have a second mesh? We do. Oh, wait. I think you have to do. I don't know, this shit is confusing. What I'm trying to do right now is I'm trying to offset the other mesh and then draw them side by side. But yeah. Oh, you know what? I need to actually change this over here. I didn't actually do this. Yeah, okay, there we go. We have two. Now we have two meshes side by side. Something else that I just realized is that we aren't drawing this. Which is confusing. We should definitely be drawing our incremental hole. I don't know. I didn't touch it. Five minutes? That seems pretty good. That does seem pretty good. God, I fucked this up while writing the other code somehow. No, we do have faces. So why are we not drawing them? We don't have any faces count at the end, but oh, maybe it has something to do with loading in the meshes twice. That M no longer has them. Okay, well. Okay, well, let's get rid of this then. Let's see if we can just render the wireframe, I guess. Okay, so we can render the wireframe. It only breaks when we add in a second mesh. So I have to figure out why that's happening. Oh wait, no, it doesn't. We load ob twice. I think 5 to 6 minutes for 4 million polygons on the CPU. It's hard to know what would be good. What's the detail on it? What was the min try? Apparently this breaks it. Yeah, this breaks it. How does that break it? Unless our verts is going out of bounds. And then it's like fucking up the stack. How does that touch the other buffer? I read that the GPU can do it instantly. Yeah, I mean, if you like I said way back when, if you do a linear BVH, you know, that will go incredibly fast. Incredibly. Let's try just doing this. Let's try doing the same mesh twice. Okay, the same mesh twice works. Oh, it's because we pass M into there. Oh. If you just do at MB0, then this works. Okay, yeah, I was just passing the wrong pointer in. Now we've translated it. Okay, that's good. So now all we want to do is move them close together and then see if they collide. Looked at LBVH. Yeah, LBVH will do it. Alright, let's see if we can make them collide. So during our main loop here, all we're gonna do is MB0 dot pause dot x plus equals 0.01f. Okay, and then we will call the GJK function. It's kind of hard to do this without like model matrices. I should probably do that. But for right now, we're just going to do it manually. Which means with our wireframe, I'm just literally going to add to each point. I'm just going to add the mesh offset during this loop. Offset equals m pause. Okay, so there we go. Now the next thing we want to do is, okay, hold on a second. Yeah, so when we call GJK with our holes, we'll pass it the offset, so that's fine. Now we just go m equals what is it? We're just gonna choose at meshes 1. Okay. And then we just replace all of this. All of this. Okay. Okay. Okay, and since it's a vector, we're fine to just do this. And let's see. Oh. Let's just see if they move. Okay, there we go. Okay, we're moving. The interesting thing, though, is that I only saw one move. When I'm only touching MB0. So one should stay. Oh, do I not make the... Oh, I don't make incremental hole with MB1. Okay. So now we have 2 holes, and one should stay and the other one should go. That's exactly what we want. Okay. So let's make this a bit slower. And now we'll try to GJK it. So, moment of truth. We're going to go MB0 dot hole with MB1 dot hole. Or, yeah, so MB0 dot pause, B1 dot hole, pause. Okay, and GJK. Oh, it keeps sending me into the wrong. Dude, what the fuck? Like, why does it keep sending me into mesh 2 instead of mesh? Like, seriously. That shit is pissing me off. Like, why is that? That makes no sense. Okay, so obviously this should just return a Boolean. For now. Okay. If GJK, and we'll have a bool stop equals false, and then if not stop, then we will continue moving. Statement requires what? Dude. LSP restart. Why? I don't have mesh 2 included. Include mesh.h. Like, why is this being fucking weird? I think I have to quit and then restart. I don't want to, though. It still is giving me an issue. So there's some like thing in my make file that would cause that. I don't understand why this compile problem is happening. It makes no sense. Oh man. I think it's because of my make file. I need to specify what it does, but like yeah, this is annoying. Alright, last time I fucking back up a file in the main directory, I guess. That's annoying. Oh my god, I'm so fucking stupid. It had nothing to do with that. I just didn't have this. Oh my god, I'm so fucking stupid. I don't know why I didn't fucking think properly. God, I'm dumb. I'm sitting here like wondering forever. Okay, so that definitely didn't determine collision at the correct point. That's for sure. It did determine it at some point, but not really. I wonder if it's this, if I'm supposed to put it at ABD. I have no clue. Or ABP rather. It's got the right spirit, you know what I mean? It's not exactly doing what we need it to do. In 5 minutes. It's pretty good. Yeah, I'm not really sure. I have no clue what the what it's like. I have no clue what would be a good one, basically. You know? I have no clue. Something else that I'm noticing here is that the vertex list at the end isn't actually the, oh my god, yeah, the vertex list after we do our hole isn't, we never update it to just be the vertices of the holes at the end of the day. Shit. When I Google if that's good, the weird Jarvis thing says it's extremely fast. Well, that's nice. Nobody builds this on the CPU. Yeah, like I said originally, like, you know, it's so much better to build these things on the GPU for a lot of reasons, you know? That is the case. Let me check the notes again. If I can catch it, it'll be good for now. Yeah. I don't think that it's that hard to port over, though. It's pretty much just copying the code. Origin is 0, 0, 0, 0. Yeah, the origin is always going to be 0, 0. Yeah, that's correct. Here's a question. If I change the initial direction, does anything change? No. Discard B and dir becomes negative A. That's what I have. Oh, you know what? I never actually... I start at 0. Yeah, so I get the support, and the support is going to be A. Oh my fucking God, bro. I dot the support against the direction. Let's try not doing that. Okay. Oh no, yeah, this makes sense because I look in the direction to find the first point. Yeah. And it starts at 0, which makes sense. So I don't think it's a stupid bug. The fact that this doesn't change anything is strange. I could check if this is facing in or outwards. If that normal is facing in or outwards. Might matter. How do I do this? You gotta go? Alright, peace out. If it's facing in or outwards, it might matter. If S points other points I, if D is greater than 0, then we have to flip the points. Which I usually go flip B and A. Maybe it's the other way around because we're facing inwards. Hold on. Maybe it's the other way around because we're facing inwards. Huh. Interesting. It should be the same. How am I handling memory allocation? Do I use arena allocation? Not really. Not right now. There's no point. I don't have like an entity component system yet in this project. Yeah, that's a bit late. It's better than it was. See my notes. Direction equals the normal of remaining points. That's what I thought, right? You just use this normal because these are the ones that remain, and then you remove the other point, and then maybe I should negate it. I can try negating it. I don't think so though. Well, maybe. Huh. That's it right there. I believe that's correct. Yeah, it's perfect. Used to be a Linux Mint user. Have decided to switch to Windows. I have a really old, shitty Windows laptop. This is a Surface Book, and so unfortunately, the case is that I require like very specific drivers for applications to run well on this computer, and Linux just doesn't have availability for the correct, notebook drivers for NVIDIA. So it's just a matter of necessity. I prefer Linux, but to be honest, I don't really think that operating systems are insanely different. The problem with Windows for me is at least that I have to use their proprietary like shitty terminal, which fucking sucks. But that is what it is. Okay, so let's test something. We started at plus 10. So let's try going downwards now in the Z direction, and let's see if it's the same deal. If it also finds that collision. Perfect. Okay, we did GJK. That really wasn't that hard. I've been live for 3 hours, but a lot of it was refactoring the whole stuff. So GJK finished. Okay, so something that I realized when we were doing GJK is that the vertices that I'm actually testing against and giving to GJK are not the whole vertices. They're the old deduplicated, decomposed vertices. So after we create the whole, what we have to do is we once again have to get rid of extraneous vertices by only taking the vertices that are within the whole. And the simple way of going about that is just going through all of the mesh faces and then catching all of the unique points, unique vertices, and then just copying those to another buffer, and then we're gonna swap them. That's literally it. Yeah, that's like the fastest way to do it. It kind of sucks that we have to do like another vector, but you know. Do I want to do just the raw vertices and then copy them? Yeah, why not? Yeah, we'll just copy the buffer from here, right? And so let's init. Yeah, makes sense. Nice thing about just using C is that you don't need too much RAM. Modern C++ or Rust. Yeah, that's a big problem. That's why I like C, is because with C++, the new compilers have to like take into account everything, and so like your build system with CMake and everything just it fucks everything up. Like right now, I just have a make file, and it just keeps track of it, and I compile like super fast. So that is really nice, yeah. Okay, so we are going to do unique vertices. We're going to initialize it to 0 with a type size of vec3. And we will just go through all of the whole.faces dot count. We will get the faces like this. It's a different buffer than it was up there, so let's just do this. I can clean this up later. I just want to get this working. So we just want to see if we want to go through all the points, right? We could also do this actually during that loop. We don't even have to loop again. We can just create this up here and then just do it while we're doing this. So new holes indices P. We need to get the vertices buffer. This. We actually haven't touched this yet, so we can literally just index straight into points. And we're just gonna nested loop through through the current amount of unique vertices. And we're just going to check if it exists. Now, the other way to do this, of course, would be to just compare indices. It would be faster, but I don't really care to do that right now. Now, yeah, unfortunately, you do have to do this, cast it to UV, and then we're just gonna index into UV by V, and then the epsilon will be this, and then obviously is unique is going to start at true, and then is unique equals false, will break out, and then we will if is unique, then we'll add onto the thing. And this makes me realize that I can do that because we don't need to get the new buffer because we're only doing it here. So vec3 pointer, we'll just call it V again, and then we'll use vector expand with that point that we just oh wait, what am I doing? We're expanding unique vertices, and that's the next line. Okay, so that should give us all the unique vertices in all of the holes. Now all we have to do, of course, we want to make sure that we free the buffer at the end. All we need to do is no, don't free this buffer. We're gonna free the current mesh hold.vertices buffer, and we will just simply swap the pointer. There we go. Okay, and now our whole vertices are deduplicated, and our whole vertices are only the ones that are used for... Oh, hold on a second. We can't just do that because our faces are actually just indices into the old vertex buffer. So it's not that simple. We have to rematch the indices. Yeah, it's not that simple. So what I have is a BLAS, but it's not a BVH BLAS. It's more like a KD tray. Yeah, did you look it up? Yeah, like a BVH it takes into account the way it splits, you know. Fuck. Actually. we can remap them here. All we have to do is, if it's unique, all you have to do is that's all you have to do. And then if it's not unique and it finds a match, then you have to set it to whatever V is here. My splits are equal, they never overlap. I split along the longest axis. Yeah. Yeah. A BVH, it takes into account the things. Does this work? I think so. I have no clue how to test it. Yeah, it's a good. It is good. I think that when you put it to the GPU, you should totally give a shot LBVHs, you know, because those are the shit. I think it's fine. Actually, something that I'm noticing. Mesh hole should equal new holes. Oh, new hole is mallocked. Well then just like do the capacity. Apparently it should diss SAT test for whatever a centroid test is. Yeah, and a centroid test is what I do for my whole BVH. It just uses the centroid of the hole. So I just make the centroid from the tetrahedron at the center of the hole, and then you just use that when you go over it. What is a centroid? It's just the center of a 3D polygon, right? Okay, GJK is done. We have collision. That's exciting. But we don't have EPA, which is how we deal with getting a normal out of it. Right now we only have if we are colliding, not if we are not how we collided or how deep we've collided. I just want to see. Oh, whoops! I just want to see if we are colliding the whole time. I just want to make sure that that's happening. I just want to make sure that there's no point where we're not colliding when we're overlapping. Before we move on, I want to make sure that it's correct. It's just the center. It's got to have more. It's so much faster. You do not want to be testing an entire triangle. Oh, fuck. See, that's what I was worried about. That's what I was worried about. I'm glad that I checked that because I almost didn't. Let's see if... Yeah, this didn't work. You should only check the actual bounds at the leaf. For actually propagating down the tree, just use centroids. That's a nothing burger. I could try a crazier direction just to make sure that it never hits negative 99 for whatever reason. I would doubt that that would be a thing. Heavily doubt. And it's definitely not AO here. I really doubt it. I could try also negating the perpendicular directions. We tried greater than 0. Oh no, but then you need... Could try greater than or equal to. Okay, well that's definitely not the case. That is definitely not the case. I tried greater than in epsilon. It sucks because I have the correct things going on here. I have the correct things going on. Let's make sure here. Let's make sure that that what I just did isn't fucking with us. Because if it is, then that's a big problem. It appears to not be fucking with us. Why would it work only on edges and not when they are totally overlapping? Is that supposed to be the case or what? I don't think that we're supposed to ever remove A. I don't think we're ever supposed to remove A. Man, I don't want to have to watch a video on if I'm doing this correctly. I wonder if I have to normalize the directions. Let's try it. I don't think you do, because at the end of the day, you're just looking in the direction. You're not actually going in the direction, so it doesn't really make sense to, because you're looking for the furthest point in that direction. So it's not going to change anything. I don't know. Am I it? Are the centroids for sorting the triangles into a list? It's so that when you are going down your BVH, you know where everything is, so that you can test against your AABB, so that you know what's in the section of your node. So basically, at your top level root node, you split everything down the middle, right? And so all of the triangles that are left of the centroid go to the left, and all of the triangles that are right of the centroid go into the right child. And then as you go down, you're just testing centroids to see where you split. It replaces your triangle test. Know where everything is in space. They don't have a size in space, only a point. So it is to find where stuff relative to a left and right split. Yeah. So you keep all the stuff that's on the left child on the left and everything that's on the right child on the right in an array. And so when you go down into the left child and you're still splitting, you know what everything in the child, what you're searching through. Does that make sense? So that you don't have to test against every triangle again. That's what I have in my BVH. That's what I've been trying to explain to you, that like when they go down, what they do is they keep an overlap doesn't matter. No, because at least in mine, because I'm doing collision, I need to have duplicates, right? So in my bottom level nodes and my leaf nodes, only in those nodes do I actually test against everything in the AABB. Just so that I make sure I have everything, right? But getting there is the important part, But I'm not even sure if most people do that, to be honest. Most of the implementations I've seen just end up with just centroids in the leaves in terms of what they're testing against. Centroids are to determine whether the triangle. So, do we then make leaf bounds from that? Yeah. There's like different ways to split it, right? Like you can actually do what you're doing with just the KD splits, but this is going to be way faster, and you're gonna. So basically, even if you're splitting in half every time, if you're taking into account like which triangles are going to the left and which triangles are going to the right, you're obviously going to have less leaves where there are less triangles. So that's the whole idea of like a bounding volume hierarchy, is that it isn't like, because you end up going down where there are more triangles. So you can still split based on longest axis, but you can also split based on the volume of the triangles themselves. Like for me it's different with my particle BVH because I have Morton codes that split kind of for me. So that's it kind of depends on the implementation. You're closer to getting it. Just look up the. I can send it to you. Just look up the. There's a BBH implementation on a website with like a white background, and it's got a lot of code in it, and that should give you a nice primer on it. Instead of testing D to find the normal, I could just compute the centroid for this. So let's do that. It's gonna be a lot of fucking bullshit adding though. No, you just do, yeah. And now I use that to dot it instead of other points. Instead I use the centroid. If it's greater than 0, then we change the normal. Before the recursive bit, loop through index buffer, get each 3 indices, the centroid, and the bounds, and group it into a struct that I can use in the recursive bit. Yeah, if you don't have like a dedicated, struct already, then yeah, for sure. And then just while you're going down, just sort the indices of that buffer. Oh wait, no, no, yeah, I am. Yeah, I'm guessing that this doesn't work. This is how I'm supposed to do the centroid, I'm pretty sure. So basically I generate an array of these struct from the indices loop, and I can use them in the split process. The centroid is just the center, yeah. Exactly. Now to think of a name. Yeah. Mine I just had, I don't know, I just named them triangles. Yeah, maybe this is not the calculation. Maybe you just dot the normal with the centroid? And you don't do this? Oh, fuck. Oh, hell yeah. Oh, hell yeah. I figured it out. I figured it out. Yes. Yes. Okay, so I just had to dot the centroid with the normal and not do the fucking other thing that I was doing with the dotting the not subtracting it from a point on the plane and dotting it. I just had to dot it with the normal. Yes. Okay. We have collision. Bounded and centroid in triangle, wink wink. I don't know about that. I would just call it BBH triangle. Like, honestly, so you could do like a generic struct called a BBH primitive, which just literally has a centroid and a bounding box. And then you can do it with any shape you want in the future. So that's probably what I'd recommend. Wow, I'm very surprised. So this was way easier than actually computing the holes. This was way easier. This is like, this, I had like barely any problems with this. So that's good. And we have collision all through the face, so that's Gucci. Now we have to do EPA, which is EPA is how you get the point of contact between the two and the normal to resolve the collisions and the depth of the collision. So that you can have bouncy shit happen. So, but the problem with this is that this is more pain in the ass than the other thing. So, this one's going to be the real pain in the ass. The good thing about this is that it actually uses exactly my incremental hole logic in here. How it uses it, no clue. And the problem with this is that I have no clue how to actually test it. So that part's fun. That's what I did. Yeah, centroiding it, yeah. Hopefully this works out for you. I mean, like, at least this is how I've been doing it, you know? And what I read from that article or whatever was that you can traverse the tree super fast when you're building it by doing this. But yeah. This is fucked. Okay, so EPA. EPA is going to give a function called collision points, or a struct called collision points, which is the furthest point of A into B and the furthest point of B into A into the hole. Okay, then we have a normal, we have a depth, and we have a boolean if it was a collision or not. The first thing we need to do is make our simplex into a polytope. A polytope. I didn't hear that either. It's completely new to me. break the simplex up into faces and vertices here into a polytope. I remember seeing EPA when I looked up GJK. Yeah, it's the second part of GJK, right? Like, we have GJK now, and it works, but now we need to figure out how to resolve the collisions, right? But it's similar to my whole algorithm, so I can reuse a lot of code, so it's not that bad. Jesus Christ, this file is already 2K lines. Okay. So we want our faces in the polytope to be different. So we have a float min dist equals infinity, and then while min dist is infinity. That's what I wrote. I'm not sure what that's about. For each face in the simplex, I think I need to do a polytope, not a simplex. I think I need to do each face inside of the 3D object that we're creating. I don't think that this is just a simplex. This is talking about the polytope. Every face that we have currently. We find the normal. Maybe we have to initialize the normals. Maybe that's the case. Okay, so we don't have to name anything a polytope. We just want our mesh faces to be a thing, right? So we want a vector faces, and we will init vector with faces. And with the type size of mesh face. This mesh face is just indices. So we want to make our first 4 faces from our simplex, that being all of them. So we can, right, yeah. So from our polytope, we have this that computes the normals for it. So inside of simplex, let's actually change the simplex struct to have a normal, that way, to have normals so that we don't have to, for 1, 2, 3, 4 faces, so that we don't have to recompute them, because we can compute them here and just cache them on the thing. So for example, our simplex normals for I will equal normal, so that we don't have to worry about them again, and we can just simply push them onto the vector here. Divided by 3 is a centroid, right? Yeah, I believe that's how you do it. I believe that's how you do it. Because I'm doing it for 4 points, and it's the same thing but with 4. Okay. So we want to vector expand faces by 1. Fuck. Fuck. Here's the problem with EPA is that now we're not working with just one hole. We're working with both. And so I can't use mesh face. We have to store the actual points. Unless we make a new array of points here that it indexes into. We could make a new array of points. We could do that. We can make a new array of points. I'm guessing for the extents, just get the min-max. Yeah, and just basically make an AABB. GJK isn't bad. It's the whole creation that's hard. Incremental hole generation is hard. Hole decomposition hard. GJK itself is this was very simple to implement. It took like an hour. What's harder, SAT or GJK? Definitely GJK. SAT is kind of plug and play. The problem with GJK is that you need holes. You need holes. Okay, so the indices will be an index into. So I hate using vectors here, but we kind of need to. This is going to be happening a lot a frame, so. If you have a lot of objects. Are you saying holes? It's hole. It's hole. It's HULLS, yeah. Hole. Maybe it's just me being an American, but yeah. Hold on a second. Does mesh face have normal? It does. It does. We're fine. Hull. Hool? I think it's hole. It's hole. That's how it's pronounced. I think you are Australian. No. No, you're joking. You're joking. Does vector expand change the count? I don't know how my own library works. It does. It does. So we're just gonna have 4 points. Haul? But that's haul. That's like when you're carrying something. That's haul. That's when you're carrying something. It's not whole. The hull is a hull of a ship, a hull of a thing. It's different. It's different. You're saying hole like a hole in the ground. Hole 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 is how it is. Hull. Hole. Hole. That's how it's pronounced. You're not gaslighting me. Hole is how it's pronounced. Hole is different. Hole is different. Hole is a ship. Hole is when it's in the ground. It's different words. It's two different words. Yeah, you're not. You're crazy. You're crazy. You're crazy. Haul is when you're hauling an object. Hole is a ship. Hole is in the ground. There's three different words. Three different words. Three different words. It's not a hole. It's a hole. You also say cash instead of cachet. Yeah, that's a problem. That's my bad. It is cachet. That is cachet. I say cash because I'm stupid. I'll let that one slide. You know what I'm not gonna let slide is the whole thing. Everybody says whole. I I think that's just an Australian thing. I'm sorry. But it's whole. It's whole. You're it's not cash. It's not. Or maybe it is. It's whichever one I don't say. It's whichever one I don't say. Because this is a recurring problem for me. That people are like, you say it wrong, and I'm like, I know I say it wrong. I have a problem in my head, but you know what? I don't have a problem with in my head with. It's definitely, there is no doubt in my mind, zero doubt, that it's not whole. I've been on a ship before. It's whole. It is whole. It's whole. It's whole. It's not Hall. No. You're not. You're not. You're not. You're not getting me. You're not getting me. How British people spell program? Nah, now you're fucking. Now you're just rage baiting. You're literally rage baiting. You're fucking rage baiting me. No, I know that they spell it like that. You're just rage baiting me though. You're literally rage baiting. Okay, the simplex also needs a centroid because we calculate the centroid here. So let's just put it on the simplex so that we don't have to recalculate it. I think it's the centroid of the simplex, right? That we're comparing against. It can't be anything else, right? Good program in English UK. What do you mean? I don't know why this min dist equals infinity is in my notes. I was watching this video from this guy, and his code just looks a bit, how do you say it? Not up to code. I don't want to be mean, but just didn't seem like something that I was gonna do. So expand hull, add horizon faces, calculate the normals of the new faces, retrieve min face, test against lowest min so far on the outer loop, push new face and normal. Okay, but how do I know when I leave? How do I know when I leave the loop? It says, well, min dist equals infinity. But I feel like test against the lowest min so far on the outer loop. How do I know when to... Hold on, let me literally just do a Google on that. How do I know when to exit out of EPA? No, not EPA employee. Programming, yes. No, not for EPA grants and financial awards. Shut the fuck up. Collision. Like, what the fuck? Tolerance thresholds. EPA works by constantly finding the closest edge. You exit when the distance of the new support point along the face is normal, minus the current distance, is less than your tolerance. At this point, the polytope can no longer expand. Example 0.001. When the distance of the new support point along the face is normal, minus the current distance. What is the current distance? ADF, yeah. For safety and performance, always include a maximum iteration, maximum support points. Get smallest distance and save normal and index. Okay, maybe it's this. If fabs have sdist minus mindist, the support distance minus the minimum distance is greater than 0.0001, then we go. Else we probably break. Okay, so then let's just do this. I mean, why don't we just do... And then just do this in the while loop here. Yeah, why not just do that? What is that noise? Well, it's kind of sad. Their dog ran away, and so they're calling for him all day. So, yeah, kind of sad. Yeah. But I'm with you on it. I'm with you on it. Thought it was somebody's screen. Yeah, I thought I was losing my mind yesterday. So, you're not alone. So for each face, we just want to make sure that we're casting every time because it just appeared on the side of my screen. I have no clue. You think you nailed it? Nice. BVH primitive gen? Yeah. You should look up how to sort it. You should find that link that I was talking about because it requires, like, you know, you to sort into left and right sides of the array, and there's a really efficient way to do it. Oh wait, I'm a fucking idiot. Don't be that hard on yourself. Don't be that hard on yourself, buddy. Come on. Let's get real here. Come on, don't be that hard on yourself, buddy. Don't be that hard on yourself, man. Come on. Let me need to test this. I can see it works just by looking at it. Okay. I can't disagree with that. change normal if outward facing. We're just gonna do the same code that we did over here. If D is less than 0. Do we want to be recalculating the centroid every time? Show you it looks good? Yeah, looks good to me. Should I recalculate the centroid every time? Or do I just keep the initial centroid? You're also centroiding it? Yeah, exactly. Exactly. Okay, so we swap it if it's negative. We're doing the Lord's work here. It needs to be a capital B. Okay, so if dist is less than 0, then we need to do the normal times -1. Wait, what? So save normal and index. Oh, right, for the mini. Right. Okay, so vec3 min normal. Vec3 min dist. That we already have min dist. My brain is like a CPU. Scale normal. I'm just thinking about how I'm gonna... I don't know what I'm gonna do to even test this. I'm writing code that I can't even test. Okay, we've saved all the information that my notes said I needed to save. Okay. If this less than 0, right. Right, no, this isn't the smallest. If dist less than smallest dist, then this min normal equals normal smallest dist equals dist. Okay. Is it worth keeping steps? Well, what I said in the beginning is that you don't really need it, yeah. Kind of sorts itself out. The min try, since you're doing a lot of tries, makes sense. But the whole point is that it kind of figures the amount of steps that you need. Okay, so now we need... So is smallest disk just min dist? Is that what it's supposed to be? Maybe that is. Maybe this is just min dist. I need the support diff function to go all the way up here. I only needed to push verts for ABC for sat, because I don't need that now. Yeah. Okay, we have the offset now. So we should just be able to do this. This. The question is, what is a dir? Wait, what the fuck is the dir? Wait, what is the dir? Fuck. Let me check this out. Dir support direction EPA collision programming. Calculate the normal of the closest face to the origin. Use the support function to find the furthest point in the direction of that normal. Evaluate convergence. The dot product, the new support. So this dir is min normal. Got it. It's kind of hard to figure that out. Okay. Set sdist. If fabsf sdist mindist then we continue. Let's also have a safety. Do I pursue programming job? I have pursued programming job. I haven't gotten programming job. That's the problem. That is the problem. It's all right though. My you know me. Programming when do job, yeah. Exactly. Okay, so this is where we do incremental hole in this case, and then we just connect the new horizon edges, and then we just loop it. We just loop it. In fact, I'm not even sure if you should do this every time. I feel like this is just a thing that you do in the beginning, and then you just do the new faces every time. I don't think that you have to do. You're only going to check the new faces, and therefore you don't have to do this. Maybe we just leave it like this for starting out, and then just refer to it later if we need to. Because this seems like a lot of unnecessary work, recalculating every face every time. It's kind of ridiculous. Okay. So how are we going to abstract this away? That's the problem. We can call the functions... we should put the functions at the top of the file because we're going to use them. We are going to use these functions: check horizon edges, add horizon edge to face. These are the ones that we are going to use. And we will try to port over the incremental hole logic into this. That's the goal. So this is basically going to be a baby incremental hole generator. Based on my notes, what did I say here? Do I have to find visible faces? Is that a part of it? Holy fuck, we got a lot of code. What did I put here? Collect visible faces. I did. I did say that. And then we add horizon faces. Okay. So really what we want to do actually is create a function that just wraps the whole thing. This is going to be a pain in the ass. I have to refactor a lot here. We should make a function that determines face visibility so that we could even abstract it better. But basically, all of this needs to go in a function. Everything from here to here needs to be wrapped, like Spotify wrapped. Okay, let's write the function. We need a check face visibility, and this is going to, what does this need? We need vector pointer. Don't forget that. Actually, we don't. We don't technically. because we're not actually changing it. Okay, for explicitness, in explicit way, let's just do that. Visible faces indices is what's going to hold the indices, as one would expect. Okay, let's just wrap it like this. It's very simple. Nothing complicated. This points is our points. Is that the CPU set check? I bet you things are going to be worlds faster. Yeah, I don't think you understand how right you are. Like, it's going to be very fast. This is what I was telling you earlier. Like, you're doing a lot of work. A lot of work. Like, this is comparing, like, one number versus, like, doing a ton of math per triangle per node. Like, that's an insane amount of insane. That's insane. What is the it's mesh hole vertices. We will have to change that later to a special hole vertices. More of that because it's a key reason I need a BVH. Yeah, it's gonna help out a lot. My internet just DC'd. So, sorry about that. Okay, let's see if this still works. Let's just make sure that I'm not making a big mistake here. Okay, holes look pretty sane to me. Okay, now we just have to wrap all of this in a function. All this is going to take in is a point and all of the other vectors. But yeah, so we're just going to bring a point in, right? Because we're just bringing in this support point. So that's what's going to happen. Okay. We need a list of things that are inside of this function. Unfortunately, this is gonna get hairy. Okay. So we have the point. We need vector pointers for everything. So in order, we need the vertices, the whole faces, horizon edges, horizon counts, whole indices, and the visible faces indices. All of that needs to go in. And now we will abstract it away. We will attempt to abstract it away. So that we can call it from the other function. So we need to replace some things here. So this is going to be whole faces, and every time we will need to dereference it. Now, of course, it is weird that we are passing these as not as pointers now. That is kind of... In check horizon edges, what do I use the whole for? I use the whole vertices? Oh yeah, I do use the whole vertices. Wait, why do I use the whole vertices? Oh yeah. So then don't take in the whole, just take in the vector vertices. Add horizon face to whole faces. This uses the whole vertices again. So instead of the whole vertices, we will use the vertices. We do need a centroid. So I'm not sure what I'll use for that. I think I need to take in a centroid. I is the index. Okay. I wonder how I'm gonna do this with the index. Like, what is the equivalent of the index? I guess for this though, we're passing in our own faces vector and our own vertex vector. So maybe it's fine. Maybe it's not fine, actually. Fuck. What is this index again? PIDX. Oh, it specifies where the point is. If I always add it... Fuck. If I always add it... Fuck. If I always add it to the end, then it should be fine. Yeah. Like, if... You could technically do that. That. But I'd be worried about how many, like, how many points we're gonna put on this vector. That sounds ridiculous. But maybe it's fine. Maybe it's fine. All right, so let's see what we need. So we already have faces and vertices. Everything else we need is hole indices, horizon edges, horizon counts, and visible faces indices. And all we need to do is free them at the end. So let's just try and grab the boilerplate for this. We expand with 4, and we should put the initial indices in here. Yeah. To link them up. This whole indices count should not be necessary because the expand does it for us. But regardless, we have it. And then at the bottom, we need to free these buffers and also free a couple of other things. Like the whole indices of buffer. Okay. So let's clean up these 2 errors. This is mad at me because of mesh hole. We instead put in the vertices into here. So this would be actually mesh hole dot vertices. Same thing with here, I believe. Okay. Now, I don't think I'm going to touch this because I'm worried about touching that. What I will do is I will call expand hole here. Holy shit, that's a lot of arguments. Alright, let's go through it. So this is going to be our support point and the index of PIDX that we just figured out. We have vertices. We have faces. We have hole indices, horizon edges, horizon counts, visible faces indices, and we have a centroid. Now just to add ampersands to all of these buffers. Okay. This is a glorious function. The EPA is crazy. The EPA is beautiful. Beautiful. Look at it. It's fantastic. Okay. So we expand a hole. And then how do we exit out? How do we extract the how do we extract the D? How to get depth and normal from EPA collision programming. Now that we have all of it, extracting depth, once the polytope stops expanding, the final closest point gives you the collision normal and the penetration depth. Which I'm going to guess the penetration depth has to be min dist or sdist. It's one of them. Maybe it's sdist minus mindist? From the origin to that closest face. Like, I get the mid normal, I get it. Or is it the support normal? Finally close the face. Distance to the face with normal N and vertex A is given by D dotted. So I guess it is mindist. Okay. So at the end of this, we want the min normal out of here, actually. You know, when I test the KD blobs, I notice something. And what is that? I also need a free vertices dot buffer, and I need a free faces dot buffer because we don't actually need to use it anymore. If GJK tells us there's a collision, then we know that there's a collision. So you would never get into EPA if... Yeah, that's whatever. So D is mindist, apparently. And the normal is min normal. Yeah. So if collision, then we want to run EPA. I named it all capital. That is true, I did. It zips through the first 2K and freezes on a few because a lot of them are just tiny little things. Things are gonna zoom. Yeah. I'm telling you that the centroid check is definitely the way to go. Okay. And we will get our collision points P out, and I want to print F the normal and the depth. And now I have no clue what a correct output is going to look like. But we're gonna give it a shot. It's literally the, yeah, that's what I was saying. The SAT check, you know, the Centroid check is gonna be insane, yeah. Oh. Oh, it's not crashing, it's just in an infinite loop. At least I think so. Oh, I didn't put P.D there. I don't think it should matter though. Yeah, I mean, triangle tests are slow for sure. Okay, so... Oh, I don't actually iter plus plus. Okay. So we have an infinite... That's really slowing us down. I mean, it is going to 500. Oh, wait, hold on. I never went... Oh, wait, no, never mind. It's a while loop, so it's going to... Oh, maybe I shouldn't be going through faces count. Wonder how multi-threaded BVH versus LBVH. I mean, LBVH is like insane. Yeah. It is insane. But it is kind of a pain in the ass to set up. We're still in an infinite loop, I'm pretty sure. If I take the safety off, we're gonna get stuck. Yeah. Oh, wait. We need to also. Oh, I do cast back on the faces, yeah. I do. Maybe let's not to do the new recursive call. Yeah, you should definitely look up the algorithm for sorting. I just pretty much followed it to a T. I should still check if this expand hole works in general, if the abstraction works in general, because I haven't actually checked that. What's it called? Let's see if this is it. How to build a BVH Part 1 Basics. I can give you it. Yeah, that one. It has a rolling kind of index thing going on whenever it splits. And I just followed the I and J method. They have an I and J index method that just works right out of the box, so I just straight up copied it. Why is it an infinite loop? Showing you how to raycast? Yeah, it's kind of, some of it isn't completely useful, but halfway down is the relevant stuff. So I get stuck in a loop here. Min dist minus s is 0.003. So so 0. Wait, so how is this less than, how is this? What? Wait. I'm gonna lose my mind. I'm glad that I checked that, because this is showing me that my code works. The value is correct. It's just not exiting out of the goddamn loop. Oh wait, no. No, it's not. No, it's not. No, it's not. It's 4.45. The support point is 4.45. That print, yeah, yeah, you think so? Min dist is 0.45. And our support is 4.45. Dot the min normal. Hold on, let me set min normal equals f0 dot normal. Let's see if setting it to something in the beginning. Your STFs are still baking. That's crazy. Okay, so that didn't help us. That did not help us. Now it's been 5 or so. Yeah. Yeah. Yeah, I'd expect as much. So we aren't seg faulting. Yeah, I only have print triangle. I would love to print these points. Yeah, you'll get it down to like very little time. Like, with an LBVH, I'd bet you could get it under like a minute, maybe. Probably even less. Probably like 30 seconds or something. Because that's how they do it. I want to print out the faces, but I need... Alright, let's get rid of the other one. We have a linker error. Alright, that should go. That should go. I believe that we have figured out the problem. We I mean, keep in mind originally it was taking... Yeah, it's a lot of progress. Should probably make this faster. Yeah, so... Where do I print out that A? When I create a new face? Oh no, that's the print try. Wait, so why do I only have one face? Why do I only have one face? Whole indices.count starts at 4. That 100% will... I see, yeah. I'm not sure what it would take to port that. Oh no. This goes around 4 times. It goes around 4 times. It goes around 4 times, and then we delete the fucking all of them. We delete all of them inside of expand hole. We delete all of them. And all the meshes, fill out the texture 3Ds with upload them to, and then just do the same logic and use image storage should be good. So I can, I guess, cut it down with BVH traversal. Yeah. Yeah, I wonder how long that'll take. Surely can't be that bad. Alright, the only way to test this out is to see if we can port it into here. We can just like one-to-one just call expand hole. It's just a pain in the ass. And I doubt that it's going to be a problem. Building is a pain. Yeah. I think once you have the acceleration structure down, it'll definitely, things will go faster. That's for the acceleration structure also extends to the SCF stuff, right? Alright, let's give it a shot. Yeah, it does, yeah. Then for sure. Did it? Oh. Yeah, well, I guess that does work. I am compiling it, right? Like, yeah, I am. Yeah, I am. What the fuck? Why does that work, but the other one doesn't? Alright, let's see the normals. Maybe the normals out of GJK don't make sense. I didn't really test that. So let's also print the normal. Let's check the normal. Well, that's colliding faster than it should be. That's colliding way faster than it should be. I guess I didn't notice before. Unless this is the reason why it's... Oh, fuck. Wait, I didn't fly up there, so I can't see. I think that that's... I think that this is fucked. Hold on. Oh my god, it is faster. I just didn't notice. Shit. Unless the face visibility thing that I changed out is something, but I highly doubt it. Huh. Okay. So we don't have it solved. Okay. Okay, let's speed this up a bit. Let's speed this up a bit. Let's not go side to side. Let's just go... Let's go mb0 pos.x equals 5, mb1 pos.x equals -5, and then let's just go, let's just so that it's easy for us to see. Oh, it crashed? Oh yeah, maybe. Where did I set the pause? Oh. How did we get this to... How did we change this before? Did we do like the normal swapping thing? Or was it us making this? I think it was us changing that. Oh man, I need another coffee. This is fucked. I just wanted to have it so that I don't have to move the camera every time to see what's happening. Just... I think that, to be honest, we need to swap these things, so I should really just not be pushing the other ones. Okay, there we go. I think I got it this time. Fucking Christ. Okay, there we go. There we go. Now we just need to separate them more, and then we're in business. I don't know why I feel like a bad programmer. You're telling me. I feel the same exact way right now. Okay, now we just speed it up a bit, and we're good. We're good to just try a bunch of shit out. I tried a bunch of things here. Really, none of them. That one kind of worked. Let's just try to get GJK working before we do EPA. I need it to be perfect, or else I'm like gonna trip out about it. Where's our... Fuck, man, there's just too much code. Yeah, so let's just not call this. And then when we hit, just stop. Yeah, that feels late. Like, that just feels late. Oh, hold on a second. Maybe wait for the... Maybe do the frame first. Maybe move it after. Move it after we verify there's no collision. No. No, yeah, we do enter it by a bit. Voxelizer and KD Bloss are almost the same logic. 100% the SAT. Yeah, but the SAT is a part of it, you know? Like, the Centroid test replaces that. It's like a, you know? Fuck. How do I render this? Am I sure that I'm rendering the whole? Like, am I absolutely sure that I'm rendering the whole? Fuck. Nah, yeah, this makes sense. Also in the future, Bistro will probably be using global chunk SDFs. Yeah. Yeah, I'm sure. Global chunk SDFs is interesting. You know what I'm kind of worried is that this is as good as it gets for GJK. Is that really true? Because it only goes based on points and not faces? And that's why you need EPA? Or no? Maybe that's why you need EPA. We could have a thing that says I love that Keshe is watching it the second time go boop in under 100 milliseconds. Yeah. I'm just gonna check if yeah, it's gonna be really good. It is gonna be really good. I need to not print this shit out, but I'm still surprised that that didn't. Yeah, it still waited till the end. Oh, because our GJK doesn't work in the first place. Oh, well, shit. Well, shit. Yeah, if our GJK doesn't work in the first place, then I guess we have a problem. I mean, it does work. It's just not perfect. 26 time elapsed. Wow, that's really fast. That was with the cache. Cache. Caching the blossom 2 might be the way to go. Yeah, I feel like that's good. Just write it to a file maybe or something that you save with the scene. That's pretty realistic. Yeah, normalizing the dir doesn't seem to do anything, so that's that. Maybe by the normal of the other points, what I'm supposed to do is not whatever this normal is. Maybe I take the normal of A, B, and C. Yeah, let's try that. Compute trinormal. The cat's being annoying. Actually, this is definitely what I'm supposed to do. I don't know why I didn't do this before. I'm like 90% sure that this is what I'm supposed to do. Okay. Um. Hey, what's up, Lily? I can load thousands of meshes. Yeah, that would seem like a pretty good thing to do, huh? I could multiply this times -1 and see if that's the correct direction. No. Wait a minute, this normal is that? It's gonna be building for hours again? Yeah. That is painful, building it from scratch. I wonder why somebody doesn't build it for you, huh? Why does the world have to be so cruel, huh? You ever think about that? Oh, fuck. You have to do that first, before you remove the point. Please? Fuck you. Actually, fuck you. Yeah, you can't really do this because this is actually the same normal that we already have calculated. So, it's going to be the same. Yeah. Yepper doozer. Yep. 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 Wee woo wee woo wee woo wee woo. Yep. 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 How to turn off these checks? I mean, I don't either. That's why I never build shit from scratch. I guess you have to. I mean, I don't know why I'm even trying this, because obviously this isn't gonna work. I'm just about ready to try anything at this point. Fuck you. Okay, yeah, this is. It isn't supposed to be normal times -1 though. I feel like this is supposed to just be the normal. I don't know why that doesn't work. Like what? Why is it the negative normal? Maybe this should be the negative normal? If that, huh. I thought GJK was so easy, and then I realized that mine barely doesn't work. Fuck yeah. Sorry. Had to get a little bit hype there. Sorry. Had to get a little bit hype. It had to happen. Okay, so let's not stop anymore. Collide all the way through. Yeah, we're in fucking business. We're in fucking business, dude. We're in business. Do you understand? You get what I'm saying? I'm in fucking business right now. Business. Holy shit. Alright, so. And the EPA is coming back. Oh, shit. I've never been more happy. I'm like a kid on Christmas. I'm like so happy. Oh my gosh, I'm gonna cry. Oh, 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 oh. Okay, so the EPA doesn't work, but now I got the GJK working. I just had to negate a normal, which is never a good sign. It's never a good sign. I'm gonna be pissed if it wants me to negate this normal. So the only way I got this working was by doing this. You hate to see it. You really do. I watched The Dictator with friends, and midway through they started prank calling their local McDonald's. It was funny. Yeah, I did a prank call once when I was a kid, and then I felt really bad about it. Because then I worked in a restaurant, right? And then I realized, oh, yeah. Yeah, yeah, yeah. Yeah, yeah, yeah. Then I got a taste of my own medicine by Mr. God. He said, dustmite. Fuck you. Fuck you. Should start a podcast? A podcast? And why is that? What will we talk about on the podcast? Yippee-doo, yippee-doo, So the min normal, we're not getting anything out of the min normal. Min normal equals normal. So I set the min normal to the normal here. Oh, hold on. Curdist equals last dist. Oh, on the first. Bro, I don't fucking know. Like, what do you want from me? Like, genuinely, what the fuck do you want me to do? But this is kind of like, but the thing is, with that, like, we already have the stream, you feel me? You smell me? So it would just be like a rehash of the same idea. The good thing about the stream is that I actually get paid cents for it. Yeah. 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 Wait, so hold on a second. We need to do a test here. I need to test something. I'm gonna be very upset in a second if this is what I think it is. I'm gonna be very upset. I'm gonna be actually pissed off. I'm fucking tilted. I'm fucking livid. Bro. Nah. Nah, you're fucking kidding me. You piece of shit. Are you fucking kidding me? I had it perfect before. You know why I had it perfect before? Because I had EPA in the thing, bro. And I was only returning true if it was an EPA collision. So really, it was just EPA that was boom, and then the EPA collision happens. Fuck. Fuck. I'm glad that it built really fast. You know what I'm not glad about? This shit. I'm about to like punch a fucking hole in my wall, man. I'm gonna lose my fucking shit. It's a little bit over in one direction, and then in the other direction it's a little bit over in the other. It's either not touching or it's too touching. Why am I not using my theme? Because you will bug me if I don't use the fucking, the normie theme. Okay? So that's why. So that's with the BBH. That's how fast it's going. That's pretty good. Do I have to worry about this normal? That's something that I was thinking about. Do I have to worry about where this normal is pointing? Or no? I already tried this. I already tried this. It's the same thing. It's the same thing. Like, what am I doing wrong? It doesn't matter. It literally does not matter what I do. I'm just leaving it what I had it. Oh yeah, you do. Oh, that's a bummer. That is a bummer. That is a bummer. It kind of lags every time it's about to touch. Or when it touches. Like, it lags. You know what I didn't consider, actually? Shut up, cat. Shut up, shut up. Alright, peace out. Peace out, Anna. Thanks for hanging out. Is your theme... the dust one is... This is dust. It's so close to working. It basically works, but it doesn't really. I wonder if I can debug print it out somehow, the simplex. But I mean, it's kind of... How do you cut? What do you mean? Oh. I don't really know. There's definitely a button for it, but I don't ever use it. Oh, hold on a second. Hold the fuck on a second. Oh my god. 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 Oh fuck. Wait a second. Never mind. I thought for a second that that I needed to apply the offset to the centroid, but I don't if the points are all with it applied. Shit. I wonder if changing the direction does anything. You made a plugin that adds a blinking cursor. No, you're joking. You're not fucking serious. Wait, it does? What? You're fucking lying. Oh, the start direction changes what happens. Oh, shit. Is that because of this? How efficient is it? Shit. Why? What is my profile picture? My profile picture is from this game Hypnagogia. Pretty excellent game. Some of these get stuck in a long loop, bro. I don't know. I'm super fucking confused at this point. Like, why does the initial direction change things? I mean, of course it's going to change the order we pick the points in, right? But I don't know. It's just impossible to really... Someone made a smooth scroll. This is what I'm telling you. Like, some people are just like sick in the head. It's crazy. It is just crazy to me. I sure as hell hope that we are rendering them at the correct positions. And I'm not stupid and we're putting them at the wrong positions. Because we are adding offset to it. How do I select a word in Helix and then put a new cursor the next time that word appears in the file? You just do backslash and then you type and then you press F. I have an idea. What if we do both at the same time? Let's try both at the same time. That does it. That does it pretty much perfectly. Let's try just one with 0. Why does 1 with 0 not work? Why is it only together? Oh wait, that does do it perfectly because of the direction bias. Huh, okay. Let's make sure I did this right. ABC, BDC, DAC, ABD. Yeah. Then the other points are correct. I know it just seems like I'm doing things randomly at this point, but it says dot normal greater than AO, and then the direction. This is still no plans for what this should be. No, it's not that deep yet. Okay, so this is where we were before, but it's too early. It's just barely too early. This is what I had before. And I know it seems like I'm like really tweaking out about this, but it's like, I think that it's supposed to be perfect, you know? Like it's not supposed to stop early. If the dot is less than 0, yeah. If you want it facing outwards, yeah. Yeah, no, that makes sense. Yeah. I was pretty mad. Am I willing to go back to trying greater than or equal to 0 here? Or maybe some epsilon? I should probably try some epsilon there. Yeah. Let's try it. I think I tried this already though. Yeah, it doesn't change anything. I haven't tried negating these, but that would go against like logic, right? Like this is the perpendicular away from it. I don't know. And compute trinormal does BAAC, yeah. So that is correct. We try something drastic like this just to see what it does. Yeah, nothing. Yeah, any more fucking I do with it is probably gonna make it worse. Now the funny thing is, if I just use EPA now, it's gonna probably give us the correct answer. No. No, yeah, EPA it waits too long. Yeah, I mean maybe it's supposed to just be a little bit early. I'm not really sure. Yeah, that. Now I wanna do a sweep test to see if it goes through the full thing. No, it doesn't. See, this is the problem we had before. This was the exact problem that we had before. And this is why I fucked with the normals before. So this was the only way to get it to work when the faces are inside one another. But maybe that's not what I'm supposed to do. Like this is what it was this. Well, that's even worse. Oh, god fucking damn it. I don't know. It works on the edges, but not on the insides. I think I read somewhere that it's just supposed to be that, but also something to keep in mind though is that I do have this like safety check. So eventually we should just run out of points. I also kind of want to check if this still happens without this like unique indices thing. Yeah, it still happens. Yeah, I'm kind of clocked out, to be honest. I guess I have a bug somewhere and I don't know how to fix it. Is this dot really the correct one? Why am I dotting the normal with AO? Let me look up what the exact test is. If the origin is on the wrong... Okay, there's a few things that I don't... If the origin is on the correct side of all 4 planes, it is enclosed. Right, so that's the case that I detect. Is... Let me see, dotting the normal of a face away from the center with AO, which should be the... I don't think that AO... I don't think AO is correct. Rename every variable to A plus a combination of numbers. That sounds terrible. Discard the vertex that is not a part of that triangle. If the origin is on the outside side of one of the face planes, so that has to be less than 0, no? No, A0 is where we just searched. So it would be greater than 0. That is correct. That is correct. Sometimes the origin falls outside the boundary of a single triangle, but is closest to one of the edges connecting the points. The edge shared by ABC and ABD. Discard the 2 vertices that do not contribute to that edge. It can be outside an edge and outside and past a vertex. I was just doing the face check. Check general. I sent a video of the cursor. Maybe I'll have to set this up. Let me see this. That's pretty awesome. I can also hear myself. That's badass. So no, that definitely is correct. They also build it differently. They do, instead of the winding I do, they do ABC, ABD, then ACD and BCD. And then the other point for each one would be D, C, E, A. Oh, you don't like the blinking cursor? I like it because I can see where I am a bit easier sometimes. That didn't seem to change anything. You did it just for me? I appreciate that. Thanks. Can you solve this problem for me? I'm just kidding. Yeah, I may have to look this up a little bit more. Maybe I should just check if the point is inside the triangle. Maybe the dotting test just isn't enough. If not worked, fix. Yeah, that would be pretty awesome, huh? I've got it like really close. Like I almost wonder if it's like I'm supposed to accept it and just do EPA, and then maybe EPA cleans it up a bit. But like this, like it works on the boundaries, but it doesn't work inside, which doesn't make sense. Maybe I can look this up actually. When the newly added support point doesn't advance past the previous simplex, and immediately branch into your resolution. Yeah, I mean, I get that. I do get that. Our point is never in the simplex at some point, which I find hard to believe. I find it hard to believe. Here's something we can try. Well, I mean, we're never going to be adding just unique points every time. Yeah, I don't know. I think that this dot check is how we check if it advances beyond the simplex. Rewriting in Haskell, I think I would lose my mind. I think I would lose my goddamn mind. We should check if I just want to make sure that my indexing is correct. Because if it's not, then that's going to be funny. So do you have that plugin on your Git? I will try it out. I've been looking for that for forever. Points before, points after. Hold on a second. Oh, wait, hold on a second. I didn't, I need to wire it up myself. Okay. Let's see what it's like. So that seems fine. Now let's see my my undoing code. Hold on a second. Okay. Yeah, but I do have an index. That is right. That is right. Yeah, I can't really find a good... a good example here. As far as I can tell, it works. Yeah, I don't know. I'm at the point where I think like failure to handle the origin inside the simplex. I think that's what I'm doing though. Like, that's what this does, right? If our newly founded support point doesn't advance the simplex in the direction, right? I think like that's what I'm already doing. Yeah, I think it might be time to bring up the video. To bring up the video with the formula. Because I'm at the point where I'm kind of lost on why it's not working when they're intersecting. It works on the outside, but not on the inside. He does less than or equal to 0, so I'm just gonna do that, which is what I had. So for the line case, if same direction AB and AO, what does that mean? Okay, so that's this. Then the dir is exactly what I have. Otherwise, the points go back to A, and then the direction is AO, which is what I have. That is exactly what I have. And then his triangle case is how different can mine really be? So crosses the normal with AC. then crosses AB with ABC, and then checks against AO. Oh, interesting. His is different. If either of those are in the same direction here, oh no, his code is just fucking confusing. That's all. I just don't know how to install Steelix on Windows. Oh, that's difficult. Yeah, that is difficult. His direction is different for AC. For AC perpendicular, the vector ends up being AC cross with AO cross with AC. Okay. Wait, no, that's the thing. He has an else here. This is so confusing. First he does the AC, and then he puts everything else in the else. Okay. So if same direction, then he does do that. But the points are, but he removes B, right? So that's fine. If same direction, AC and AO. Okay, if vector.ac and AO is greater than 0. I'm going to make it so you can install Steelix packages declaratively. That sounds like some wonderful stuff. That sounds like some Nick stuff, huh? What does direction... He has a direction thing. And so what he does is he just makes direction equal direction, equal the last direction, I suppose. But if the direction is the last direction, aren't we just going to add the same point twice? And then his points end up going A, B. So he removes C. Okay. So if this is the same direction, then he returns this. Else, if the dot of A, B, C, and AO I'm sorry, I'm so confused. And then he removes B and then negative. And then the dir equals totally zonched right now. Absolutely zonched. Okay, so this is going to, we're gonna keep last dir in there. Okay, it's the same thing. After all of this, it was the same thing. Let's just make sure that we did everything correct. I hate also how this guy has, if it's the same direction, it's like, dude, just like dot it and then tell me, you know. ABC, which is normal, crossed with AC. Right. The ACP dot it with AO. And then if it's greater than 0, then we check if the same direction, if ACAO is greater than 0, then our dir becomes ACAO, cross with AC again to get the perpendicular. You remove B from it. Otherwise, dir equals the last direction, and you remove C. And if that isn't the case, then you do if ABC and AB and ABC, which is this, ABP, dot with AO is greater than 0. If so, then you return, oh, dir equals direction. Okay. And I do remove C, yeah. Okay. This somehow made it worse. So take that with what you will. Oh, I'm supposed to get rid of D. Or what? It says to reorder the points into ACB. Huh. Okay, well, we can make a thing here. How are we gonna do this? ACB. Array subscript is not integer. Oh, what the fuck is my problem? Brr. I haven't got to the tetrahedron point of the video yet, so this is what he says to do. So, oh, you're not supposed to remove a point, duh. Who's up tonguing it? Tongue. Just kidding. All right, let's see. Let's see what he says at the end. ABC, ACD, and ADB. I don't trust this guy. Why are you only doing 3 triangles and not 4? ABC, ACD. ADB. This is what he says. He says to only do 3. But I don't tell how you're testing if it's inside then. Like what? The fuck? He hard codes it. I'm just gonna give it a shot at this point because I'm on the verge of getting stuck. So I'm just gonna give anything a shot. And the other ones are ACAD and ADAB. So okay. That can't be right. Yeah, it's ACAD. Okay, so instead of this, he says to dot each one. Wait, does he dot it with this? He does it with AO. See, this is what I was thinking. Oh wait, no, but I swap it just in case. It's interesting that he doesn't swap it. But he does it like this. And he always puts the dir as the Oh, he keeps the same direction. Is this serious? Untitled 3D project in C. It is. Huh. He keeps the direction. ABC, ACD, ADB. ABC, the first one, we actually can just get rid of D. So that's gonna be that, right? Then for these, he says to get rid of the other ones, but you have to reorder the points. So for this one, it ends up being ACD and then ADB. So ACD you can actually just get rid of this, but ABD you have to. Is ABD? Am I doing that right? Is it D on top? It's AD cross AB. Okay. Yeah, it's ADB. I had it backwards. Okay, so now you need to. We can remove. Let's just do it manually. So let's go S points B equals S points D. And yeah, so Alright, there it is. That's equivalent to that. Okay. That's a lot better. That is a lot better. That is a lot better. I wonder if I should cross with the Centroid to determine if I need to swap any of these. Or, I mean, not cross, dot it with the Centroid. Yeah, it's d greater than 0. Or no, it's d less than. It's d less than. What the fuck am I talking about? I guess I should have just copied it. I don't know. No, not really. It's just before I fuck this up, just calm the fuck down. Oh, but then if I swap them... Oh, but then if I swap them, I have to actually swap the points. Ah, shit. Yeah, that's complicated. That is complicated. Yeah, it doesn't work anymore. It doesn't work anymore if you do that. Yeah, it starts colliding like pretty late. I wonder if I go back to what I was doing before, if it's fine now. If I go back to what I was doing before here, maybe it's fine. Because this looks so fucking complicated. Like, the notes that I had for case 3 were... Maybe my dir is supposed to be... I'm supposed to keep the same direction, though. Maybe reordering those points is the problem? No. Maybe I need to check the last face. Maybe I need to check the last face. What would the last face be? It's DIC, right? No. It's BCD. Oh, removing A from the simplex seems to be a problem, though. That does seem like it would be a problem. Yeah. Okay, so that was the problem all along. The problem was that we were checking a bad face and discarding A, even though you're never supposed to discard A, obviously. I want to see if the normals are ever wrong, because if so, then we may have to reorder the points or something. Wrong. Yeah. Hold on, isn't it? No, it's less than 0. It's less than 0. So you don't want it facing towards the centroid. Fuck. Okay, now yeah, my addition here of flipping the normals is definitely correct. It's definitely correct. It just collides too late. Let me see if there's anything else. Anything else that I missed? I don't think so. I might try dir equals AO at this point. Huh. That time it seemed a bit early. Yeah, it kind of got fucked there. Hey, what's up, Lily? You sound extremely tired. I'm alright. It's just I'm so close to getting it. It's really, really close. I almost want to kind of like just start over on this section and just give it a shot again. Because this is, so it said this there, but I'm thinking like this is what I had in the beginning. But this seems like a crazy, crazy, crazy thing. Don't you want to like, shouldn't this be the same just for AB? Like that's the part that's confusing me. Like, shouldn't those be equivalent? And then the only thing you have to do is just this part at the end, where you just dot the normal with AO, and then you do this. Like, I think that the rest of the stuff is just extraneous. Like, I don't see the point in it. Like, doesn't make like logical sense to me why you would want that. Oh, well, I fixed it. See? I know what I'm doing. Kind of. Are we done? I think we're done. Yeah, so I had to just undo what I just took from I took that from somebody, and then I just like realized now that it's incorrect code and fixed it. And that's perfect. Well, is that not My friend prank called Starbucks and asked if they sell coffee. You sound a bit... Oh. Holy shit. You got fucking owned. Like, you got fucking actually decimated. Jeez. I would get a grip if somebody told me that. I would immediately get a grip. See, so this is the problem that we had before. Like, are you looking at this? Are you seeing how close that is? Like, we can't be serious. It's so close. Hey, don't knock the Starbucks workers. I think everybody, trust me. I'm not saying you're going to become a Starbucks worker one day, but I have been a Starbucks worker before. Not at Starbucks, but metaphorically, Sort of like, in the vicinity of being a Starbucks worker, And it's not fun. It's not fun to get prank called. It's not fun to have to go to work and realize that your life is a fucking waste. It's pretty fucking whack, bro. You feel me? Oh, dude. They did the same thing, but they asked you to sell chicken. That's wild. I would kick the shit out of that kid. Now I'm just copying the same thing. See, removing this from the simplex makes no sense. That makes no sense. I'm sorry, that makes no sense. What did the KFC worker say? Did he say like get a grip? They just hung up. Yeah. I had a... a couple of prank calls. I don't really after I did one, I immediately kind of felt like, oh, I'm kind of a dick. You're a victim of unending gluttony? Why? Why the gluttony? It says that on my notes, I said that the direction was the direction of the remaining points. And so I think I'll just try that. No, I thought it was it. Oh my god, I got so hype. I was so fucking hyped for a second. Holy shit. Oh my god. That would have been crazy. That would have been fucking off the chain. I'm always hungry and then I get fat and then I get sad. Ah, man. That sucks. I always had good metabolism, so I never really had any repercussions for eating. I typically don't eat very much, to be honest. That's just the way it goes. That's just the way it goes. That's just how it is. You know that song. Who is that song by? Ah, shit, wait. Hold on a second. Hold up. Oh my gosh. Oh my gosh. By golly, I think we did it. Hold on. It's perfect. It's perfect. So we didn't need to swap the normals. I don't know what. Holy shit, it's over. It's actually over. Oh my gosh. I'm so happy. I'm gonna bake me a cake and I'd call it my birthday. Look at that. It's the exact point. It's perfect. The collision. Look at that. I couldn't have done it better myself. You're having trouble implementing the thing? What thing? Dude, I'm so happy. Holy shit. I thought for a while I wasn't gonna get it. I just had to randomly code things until it worked. Okay. So the thing is that just because this works doesn't mean that our EPA works. And our EPA is what matters. That's the next thing that matters. Oh shit. Well, we started getting something right from the EPA right when we started colliding, which is good. But what if we try to go through? I bet our EPA stops working. Holy shit. Wait a minute, it's working. It's all working. It's all working. I mean, I don't know if it's... like, let's be honest here. Like, what am I supposed to look at this normal and then, like, see if it's working? No fucking clue. Dustmite, you should give the shape you're colliding a name. That's a good idea. How about you name it? Why is the depth oscillating like that? Why is the depth oscillating like that? Depth seems a bit random, I'm not gonna lie. Oh no, at the beginning, and then it starts to go up. And then it starts to go up, and then it starts to go down. Aldo? Okay, got it. Or Aldo. Which one is it? I want to make sure I get his name right. Isn't that like a dog name, huh? Aldo? We might get infinite looped here. Infinite looped. Lovely. That's exactly what we like to see. Aldo. I don't know if I'm doing this right. But like how am I supposed to how am I supposed to test it? Wait, hold on. Isn't this backwards? If the centroid and the normal... Nah, yeah, it's the... I'm thinking too hard about it. Oh, you're an Inglorious... You're that big of a fan of Inglorious Bastards. Got it. Is this right? Yeah, the depth doesn't seem to really work, huh? The depth does not seem to work. Unless min dist, unless we're supposed to do curd dist, no. But that's underneath that, so... You know what? The face already has a normal, doesn't it? The face already has a normal. Totally didn't think about that. Yeah, I did assume that the kill bill is supposed to be killing the bill. It's crazy that I was right about that. Dist equals dot normal and a. Really? Wait, what? This is the normal dotted with A. Huh. Interesting. I don't know what that's about. She kills Bill? Yeah. I think I remember that. See, now we're getting zeros. So I'm gonna guess that we have to... Okay. I guess that face doesn't have a normal. I guess that those normals don't have a face. But then again, with the depth thing, like, how do you know? How do you know? Like, how reliable is depth? Let's test something. Let me ask. Let's ask Google how to get depth from EPA collision programming. Calculate the closest face on your Minkowski difference polytope to the origin. See, that's what I thought. But whole indices is what we start at 0, yeah. Loop all of the faces and determine which face F is closest to the origin. Calculate the distance from the origin to the closest face where V is any... If P nu is not significantly further from the origin in the direction of N than your current closest face, you have reached the boundary. Huh. I think it might be that our simplex just isn't on the deepest face. To be honest, so I think that it's probably correct. I mean, it's hard to figure it out, but I think it's correct. If we want to test, what we can do is, instead of just adding y, what we could do is we could start off, we could have GJK first of all return let's just take in collision points pointer P, collision points, and then let's just do okay, let's just assign it like that. Let's just take in a pointer, collision points, pointer P, And let's just, or I meant this. Let's just pass in that. Too many arguments. You're lying. You're just mad because I didn't put it in the header. But silly you, I'm about to put it in the header. What do you think about that, huh? What do you think about that, punk? And then we have a movedir, which will start off as 0, 1, 0, which is where we're gonna move, where we've been moving, right? And we will have a float step, which will be 0.001 f, and we will simply just apply the step. mb1.pause equals vec3 add vec3 scale movedir with the step, and we will add it to mb1.pause. And when if GJK, then we will get a new thing in our collision points, and all I want to do is move dir equals p dot normal, and we should change direction. Oh, we're flip-flopping. Our normal is flip-flopping. Oh. Would you look at that? Why is our normal flip-flopping? Well, that's annoying. You're gonna fork Helix and call it dust? Thanks. I'd hate to take credit for it. Yeah, I'm not sure. I wonder if it is that, but this doesn't give us anything then. Oh shit. Oh shit. That's cool. You finally got a piece of meat out of your braces. Damn, that's rough. Fuck. The normals are flip-flopping again. I wonder if that's fine for that to happen, and we're just supposed to resolve it first. I think you're supposed to move it out by the depth amount. Yeah, so sure. Let's just go that pause equals vec3 add mb0.pause plus P dot D now we're gonna push out by the depth value so that hopefully we don't flip-flop anymore. There we go. I wonder if you run this so many times, you know, if we ever are gonna accidentally flip-flop. It's strange. If dist is less than 0, then we flip it, right? So I don't know what would cause it to be problematic. We should also have an iter safety here. All right. We have collision. I'm just making sure that it's the exact angle. I think so. All right. That's pretty sick. That's pretty sick, don't you think? What do we think? That's pretty sick, right? Anyway, I'm gonna make some more coffee and then I'll come back, I think. Things that I want to do. I want to make it so that we can walk around, obviously. I think that would be pretty cool. We also need, we're going to get to the point now where we need a system to load in multiple meshes and deal with that. So like, you know, have an array of meshes, and we still have yet to do whole decomposition so that we can have convex meshes. But what I want to do when I get back is just literally make some ground so that we can walk around on, and I want to do the collision movement, like resolution, that sort of thing, because I think that'll be quite fun to cap out the day. I think our EPA is working. I think our GJK, I finally got it working. I kind of just like brute forced it at the end because I couldn't really figure out what to do, but then I figured it out. Okay, I'll be back in like 10ish minutes. So. Okay, my coffee isn't finished. It takes a while to drip, so. All right. Okay. So, we're not going to worry about an acceleration structure for all of the meshes. All we're going to do is at least have something that when we load in meshes, we push it onto an array. And I believe that we already do have something like this. I believe that we push it onto... Man, there's too much shit in this file. Yeah, we push it on to globals.meshes. Okay, and for now, we have a camera.c, right? And so what we're going to do is pretty much apply planet velocity is what we're going to focus on. We're basically going to do this. And to resolve collisions. Except I don't have the collision resolving code. So let's just grab that real quick. I believe we should have it in here. Find surface entry. Where is hit ground? Check collision. Right, we have hit ground and all of that. Resolve collisions. So this is basically what we can do. Resolve collisions, the same thing as this. It's just going to be copying the overall structure and like the math for the resolutions. Obviously the method is going to be a bit different since we have GJK now. GJK is fucking awesome, and I'm so happy that we got it. Anyway, so before when we had collision in my previous engines, we had a concept of what was walkable versus not, right? And so we would hit the ground. Now we really don't have that. So we have to figure out, you know, what's going to feel good and all that. First thing I want to do, though, is just have a no-clip ability. Where are my input? Process input. It's in input.h. I was smart enough to make a new file for this. That's first. So in my previous engine, I had T was the button that did it. That toggled the toggled whatever no clip was. I don't know what it was referred to in here. I'm just gonna put it in globals, and it will be bool no clip. Oh wow, that was lag. And no clip will start on, of course. Fuck it. Yeah, that's always lame that you have to initialize. Well, it of course makes sense, but in my perfect world, I would create a compile time checker for that so that you could get around it. That would be awesome, but Okay, so T now toggles no clip mode. That's all we care about. And inside of input, we should have the apply velocity, right? So obviously, if globals dot no clip, if not globals dot no clip, then we want to apply planet velocity, which is just the version of apply velocity that has gravity, right? Apply planet velocity, I have no clue what it does. I've got some constants like gravity, etc. Times dt, camvel, apply air acceleration. Right, so yeah, we had this concept of if you're on the ground, it behaves differently than when you're in the air. I don't know if we're going to keep this, but I just kind of want to make sure that the collision works and verify it by walking. So I guess we can just keep that fine. Okay, but resolve collisions, right? So we had a global thing here. For if the ground has been hit in a frame. I don't know if we're going to keep that. All of this, obviously, we can get rid of because that isn't... We aren't in the space sim anymore. We don't have to worry about the timers. So that's something else we can get rid of. Don't have to worry about the voxel size. Okay, so here we hit our first thing, right? So find the ground. The thing is, right? Okay, we can only collide with a certain mesh once, right? And so if we're doing like a continuous collision resolver, what we literally should do is just simply run GJK with our collision hole, and then just keep running it until we are out of you know, whatever, out of every surface. Also, something we have to figure out. We have to initialize a player collision hole. Because it needs to have a collision hole, the player. Now, I like to keep player data, you know, I don't like the whole idea of having player, you know, defined data because it's non-modular. In this case, I think we absolutely do need, though. And this will have a convex hole. Even though it's just an AABB. Even though it's literally just an AABB. Does a convex hole has an AABB inside of it. So that's absolutely already fine. We can literally hard code it ourselves. Also, a player should have a radius. Slash silly is pretty funny. Yeah, my coffee's almost done, really. So we're gonna have a radius and a height. And let's have a big decision here. Let's have a pointer to a camera. Reason being, we want to be able to switch between cameras. And I remember having to refactor that in my last... You're back. Apologies? You don't have to apologize. You know, I'm going to be here if there's anybody here or not. I've been here, you know, plenty of days where there's nobody here. And also, plenty of days where there were people here. It's pretty funny. Like, when I first started streaming, we would, like, regularly get, like, you know, 40 people in here just like randomly, you know. You know, it started off, it was just Arya, and then, like, you know, people would just like start, you know, but I haven't had that in a long time. I think maybe it's because I'm boring, but you know, whatever. Okay, so on init, we want to is init.h where I have everything. I'm just gonna extern player just so that we have our regular player, and this is what we will initialize the data for. I really want a pizza. I had a pizza last night. I did. Okay, so what we will do, we need to init the collision hole for the player. It's important. So this is just going to be our hard-coded constants for now, of course. So for our global player, we will have a radius of 0.2f. I have no clue what that is in world space and what that's going to be like. We want a height of 0.8f. So like the typical values. And the player.cam will reference this cam. And the hull is what we will generate now with that data. So we want to get a convex hull, corner hull equals this player hull, and we will start filling this up. Okay, so a few things we need to do. We need to get our 4 points, or our 8 points for the rectangular prism collision hole, and we're going to make them based on, of course, the radius and the height. Right. Okay, so let's say our bottom is at 0, 0, because that's... Do we want it at... We can translate it later. But for now, let's just make the center in between the height and the ground. So this is going to be vec3 center is height divided by 2. You love Nix. I think Nix is pretty great, yeah. Yeah, so let's make the center is going to be so our center is going to be our radius divided by 2, right? Oh, we probably want it, we probably want, okay, so let's go negative radius, player radius divided by 2. And negative player radius divided by 2 on the other axis. So basically what I'm doing here is I'm making it so that our center is at 0, 0, 0, except for the height where, you know, we want it to be at the bottom in Z. Okay. So to make we're gonna have a vec3 extents, which will be wait, hold on a second. Am I? Oh, I'm dumb. Oh, I'm dumb. Oh, I'm dumb. I'm dumb. You should just install NixOS and just steal my config. Unfortunately, there are laws that bind me to Windows for now on until I get a new computer. Okay. So now we need to make 8 points. Why I need a new PC? Because this one sucks. Like, really bad. Like, it's a laptop. That's why I need a new PC. I stream from a 15-year-old PC that has a capture card that's linked to this PC. So that's why I need a new PC. I'm just trying to see if I can do this in a loop. I probably can. In fact, I definitely have the code that does this somewhere. May have gotten rid of it. My real name Dustin? You think my real name is fucking Dustin? What? Dustin? Really? Do I give off Dustin vibes? Dustin. Dustin. Fucking Dustin? Ah, shit. Yeah, this file's a big one. This one's a big one. Alright, this is what I'm looking for. Yeah, this code. Yeah. This is the exact code, yeah. Just thought it's similar to dustmite. Yeah, I would hate to be named Dustin. I'm not gonna lie. That would be like top few worst names for me. Okay, so we're gonna do the same thing here. We're just gonna add the center to this times the half extents, and then just keep adding it. Yeah, don't you just do vec3 x y z mole. Don't you just do that? I think so. Jake? The fuck? Jake? Are you being fucking funny? What? Jake. Jake. Okay. I all right. I think you have a bad perception of me. I think you have a bad perception of me. I think that that's just the case. Jake? Crazy. That is fucking crazy. How many faces does this shit have? Let's be for fucking real right now. 1, 2, 3, 4, 5, 6 times 2. And then vertices. And it has 8 vertices. Alright. I have to finish up my coffee. Do I have a guessable name? Probably. I don't know what guessable entails. I feel like it's pretty kind of normal. But I don't think I'm going to tell you if you guess my name. Just to be upfront. Okay. Are we sure that it's 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, that's fair. Right, so this is each point, rather than... Right. Okay, so corners in order. Right. Okay, so in this case, then this is not going to be corners. It's just going to be vertices. Oh, I forgot to put this as vec3. Okay. I'm not telling you if you guess my name, but no, my name is not Adam. I think Adam would be all right. That's acceptable to me. Definitely not it though. Oh, okay. So I have to do this on the way down. So 1, 2 will be 0, 3. It's gonna be a pain in the ass. Two, 5, 4. I'm glad that I wrote this code once that did it, so I never have to make a cube by hand again. I'm very lucky for that. That's what I'm doing, by the way. I'm making the collision hitbox for the player. That you think that that's my name? I wish that was my name. I feel like I probably would have gotten a coding job by now if that was my name. Do you think? They'd be like, holy shit, he was made to code. Absolutely built to code. Okay. Last one. 7, 2, 6. 7, 7, 7. Yeah. Now I have no clue if the winding of these faces are correct. Okay. Now, do I have to compute the normals for these? I don't think so. Maybe. Where do I use the normals for them? I mean, don't I basically calc them on the fly? I think I do, pretty much. The website for Steelix plugins is vibe coded? I'm not surprised. I'm not surprised. Sorry, I'm just not very surprised. I don't know where I used the actual face vertices, face normals. I recalculate them here. I use the simplex normals when I do that. Yeah, I'm not sure. Thing is, I don't even need to make, like, I don't even need to put it into the function since I'm just hard coding it. So really, it's fine. I think if we run into trouble, then we can figure it out. But for now, that's fine. Also, I thought there was 12 faces. Why do we have 8? Oh, fuck. Oh, fuck. What is this, then? This is 8 triangles. Oh, fuck. Try Cocoon? I feel like trying Cocoon after Helix would just be doing a step backwards, to be honest. Fuck. I might actually have to draw this out. On like a... What is Sam? Okay, so then try. I'm alright. I may have to draw this out. Do I have paper? Oh, I don't want to fucking do this in my head. Why is this not a rectangle? Why am I missing two faces? I guess I just didn't have a bottom and a top. Fuck. I mean, how am I gonna figure this out without like visualizing it? Oh my god. It's probably better than Helix. Do you just get like a new opinion every day? That's like crazy, dude. Helix made me, you know, I became good at code with Helix. No, please try it. I think I'm alright. If I just have the 8 vertices, can I just generate a hole from it somehow? Can I just plug that into incremental hole or something? We don't actually use the... We use mesh tries. We use mesh tries for it. And then we push it onto whole vertices. So it goes from tries. Because that's how, when we load them in, it goes to tries first. We could change that. We could change that and make it just go to vertices instead. Which seems like a lot of work, but maybe it's fine. And then that'll mean that we can just give it points without anything else. And that'll make our lives a lot easier. We do have a vector for vertices. All we need is a vector then for tries. We already have a... Yeah, so this tries will just be... will just be mesh faces then. What's my favorite coffee? I don't know if I really have a favorite coffee. I like this Vietnamese coffee thing that I have. Yeah. I do like coffee, but I don't really have good coffee, unfortunately. So we don't want to knit this with size of triangle anymore. This is going to be mesh face. And we will wait, hold on, not we want to put vertices, and then vertices will be point. We will expand by 3, and that's where we're gonna put all of this shit. Click behind the line number. You get the dot, which is like a bookmark or breakpoint. All right, peace out, Lily. Thanks for hanging out. Okay. And then we can put this on try. All right, this is likely going to break something else somewhere. But that's what we'll do. And then that's what we'll take from when we do our decompose, which isn't really a decompose at all, but we'll just loop through the raw vertices from here. Okay, that's how we'll get our vertices now. I just want to see if we can compile this right now as it is. Looks like in input we have some thing to figure out. I'm just gonna not worry about that. Now in camera, right? Yeah, we didn't finish this function. So let's just comment the fuck out of it. Okay. What else? Yeah, just we're working on it. Okay, so we have our points that got generated regardless, which is exactly what we want. And we go from mesh vertices to the whole vertices, which is perfect because now in our initialization here, we don't have to do any of this, hopefully. All we have to do is call is called the incremental hole. Oh, but it's on a mesh. Fuck. Does it really need to be on a mesh? Pick lowest point. All of this is from the hole, no? Oh, but the decompose. Oh, wait, no. Yeah, the decompose comes from the mesh vertices. How fucking cursed would it be if I gave the player a mesh just so that we could feed it into, so that we didn't have to do this by hand? The amount of fucking going through hoops that I'm doing just so that I don't have to do this is ridiculous. But I think I'm gonna do it. You hate to see it. You hate to see it. We hate to see it. Right now we only have one hole for everything, so okay. We are going to call on this mesh incremental hole. Okay, and that should make an incremental hole with our mesh vertices on a knit. Now what this allows us to do is okay, so this is gonna have to change a bit. Instead of finding surface, what we will do is we will check for collision using GJK. We will project out by the normal that we get, and then we'll just do it in a while loop. I'm just probably gonna rewrite all of this, to be completely honest. So let's get our collision points P. We will have a while loop. Is resolved equals false. And while we aren't resolved, we will go. We will go until we're outside of every surface. So we come in here with a proposed, right? Where we add the cam pause to cam vel. Okay. And so we are going to use that proposed as our offset to check GJK. If GJK, and we have our two holes, and obviously we have our player hole using player.mesh.hole, and the A offset is going to be the proposed, and B, well, we don't really have a system for this, to be completely honest. What we'll do instead is we will just have a wrapper function that oh, my coffee is still on the screen. We'll just have a wrapper function that just loops through and finds one collision for GJK. Find first collision. That's what we'll call it. And we don't even have to put anything into it, I think. We just take proposed. And we'll just go through our meshes. Unexpected type name mesh. Oh, it's probably because of this. It's probably just this. No? Oh, there we go. I just didn't have utilities included. Okay, so we have our meshes. So we're just going to go... Just for now, we're just going to check against every mesh in the scene. Later, we'll have a BVH. That's going to be soon. Okay. So we're going to take in proposed. And we'll be checking against the convex hole of that mesh. So, and then the offset of the mesh is going to be mesh dot pause. And the collision points, will be, we have to give a pointer to it. Actually, yeah, so let's just take in a pointer once again. If GJK, then we want to return early. And we want to set p.collision equals false at the beginning every time, right? And so we will find first collision using proposed, and we will pass in p. And now if p.collision, if not p.collision, then we break, right? It's that simple. Otherwise, we need to move. And the code for this is here, right? We take the dot of the wish and the collision normal. So our wish is the proposed minus the cam pause. Maybe not cam pause. Because we may have to change it during the... I don't know. Fuck. Am I supposed to use cam pause or start pause? What am I drinking? Just coffee. It's like Vietnamese coffee with some condensed milk. Fuck. Am I supposed to use cam pause here or like, because if I keep on moving proposed, maybe it's fine. Maybe it's fine. Let's just keep it as it is. We're going to dot it with the collision normal, which is p dot normal. That's what we got from EPA. And then we're just going to translate all of this to here. The collision normal will be p dot normal again. And we will change and then instead of just validating this here, really what you want to do is you want to validate this here. Instead, we'll just keep going until it's whatever. You also want a safety here. I'm gonna say like something small, like 5. Let's go 10. You always want a safety. Okay, and this should theoretically do something. Theoretically. Now we don't have any way of knowing when we're on the ground, but whatever. Something that will be problematic though is that our meshes are currently moving, and we also can't necessarily see our meshes. So that's immediately going to be a problem. But we do have meshes, and they are at some position. We just don't have the ability to actually move them via model matrices yet. I don't have that set up. But, oh my god. Okay. The gravity may be a lot. I just kind of okay, well, like, okay, so it looks like I'm not colliding with anything, which is really not good. I had it here. Oh, this is 36 verts though. Oh boy. Hold on a second. I think I'm supposed to put this into mesh dot vertices. Okay. How about this? Let's just put this here, so that we're always going to be. I'm getting very rare collisions. I wish I could see what my. I wish I could see what it looks like. I can probably actually. Okay, so let's actually do this. Let's render the. Let's render the player collision box. Okay. Let's just not offset it. Okay. Let's just print out how many faces we have. We have 0 faces. Okay, so that would be the problem, is that we have 0 faces. Oh, we never call init player. We never call it. Oh, you silly goose. You silly goose. I was so confused. I was like, what is the problem here? Oh. So now we have 4 faces, but it's just a... It's not a thing. Huh. Fuck. Why is it not a thing? Shit. Hold on a second, hold on a second, hold on a second. Ah, that's points. That's points. It's I need to point. And that's the box. It's a very small box. And we aren't detecting any collisions with said box. But it is a box, okay? So we do have a box. So that's something at least. So why aren't we detecting any collisions with it? That's the question. Oh, wait a second. Oh no, we're going from inside GJK. I'm just checking where we're printing out from. I only want to print out when we have a collision. I want to see if we can get any collisions. Oh. Okay. By the way, we're not actually, our hitbox isn't actually there. We're just, wait, maybe we are. No, it's offset by that position. Offset should be player.cam. Fuck. Why the fuck did I do that? Why did I do it like this? Can someone tell me why I did it like that? Okay, so we have a box on top of us, which is pretty fair, pretty par for the course. So our collision is only happening there. And over here. Colliding a lot over here. Huh. Okay. Let's try something. Let me make sure that our... Instead of proposed... Maybe try... Campos? Okay, so I see what's happening. GJK is telling us we have a collision, but EPA is telling us that we don't have a collision. Which doesn't really make sense. Maybe we just don't trust the EPA collision nonsense, and we just trust GJK. I think that's what I'm going to do. I don't know what condition I have it under, but... My bad. Wait, what? Oh, I wasn't printing out anything. Wait. What? Well... Well, now I'm confused. What the fuck is wrong with me? Oh, I never got... Well, I mean, this can't actually be the bug, though. It's not gonna be the bug. It's not gonna be the bug, because it wouldn't cause that. Oh my god, it is the bug. Wait, what? Oh shit. I'm clipping into the face though sometimes. Oh, because I'm not resolving it. Okay, we fixed it. I thought that I was gonna go crazy there for a second. Like, holy shit. I was gonna get tilted. I was getting a bit upset. Okay, we are clipping through the face, which is not what you want to see. We do clip through the face. Let's see if we run out of shit. Let's see if we run out of shit. Okay, this count has to go away. This count has to go away. Fuck. Oh, ran out. That's what I wanted to see. That's what I wanted to see. Can we do this? Then we don't get anything. But I'm worried that we aren't getting a correct normal back. From EPA. See, that's the thing, is it's giving a different normal every time. That's the problem. And I don't know how to make it give a correct normal. I already tried to swap it based on direction. Okay, that's definitely... Oh no, it's still... Yeah, it's still the switch. I don't think it's this. See, the thing is, the centroid is the centroid of the simplex, which might not be... But how do I choose which normal... Huh. Let me look this up. Oh, another hack in the Discord. I gotta ban that guy. Copy user info. Got it. Did it. Okay. Now what I was gonna look up was how to take normals from EPA. Because of the winding order, this calculate to normal might or outward. Calculate the centroid of the polytope. Take the dot product between your face normal and the vector from the centroid. If the dot product is negative, the normal is... Yeah. Actually, maybe I can just like... do this. See, it sometimes flips. See, it flipped there. The normal flipped. Maybe I don't need a double. That seems a lot better. It is still flipping though. I could do this after I do this. So that means that it's always definitely facing the right direction, right? Yeah, maybe I do have to update the centroid. I'm not sure. I could just update it each time. Every time we add a support point. You know what I just realized? Aren't we adding onto our points? So why are we not updating the points pointer every time we add support points? Am I stupid? That should be important, right? There's yeah, it still is switching. Well, let's just go through and let's go. It rarely is flipping sign. It is just flipping sign. No, it's not. It's not whole indices that count. It's actually vertices that count. That's what it is. That felt good. Ah, yeah. Uh, it says to literally just orientate it based on the object's center of mass. Is what it says, but I don't know if I should really trust that. Like, it says just to do this. Yeah, I don't know. Yeah, I'm not sure. It's like 99% the correct Fuck. Maybe it also has to do with the winding of... I don't know. Yeah, that makes it worse for sure. You definitely don't want it to be that. That's the wrong direction. Yeah. I almost wonder if it's our simplex that's coming in that has bad winding somehow. Yeah, nothing that I'm looking up is actually giving me any answers, so... This is fucking annoying, man. I don't know. I could just like orientate the normal at the end based on, you know, what it needs to be, but then that defeats the whole fucking point of having a collision solver. Like, maybe I just don't fuck with the winding. This is a lot better, but I mean, it's just a band-aid solution really, because you can still, like, I just obviously went in here. Okay, so from what I understand, we're just hitting the safety. Like if I put safety to 10, I don't understand how we're not getting pushed out of the surface. Maybe it's because of the flipping normal thing. Yeah, we could manually just flip the normal for now, but I want to figure out why it's doing it. I don't know. There, I just got stuck for real. I think, I don't know. Like, maybe it's our original winding here that's incorrect. ADB, ACD, ADB. Have I gone insane yet? Not really. It's just I have this problem where with the new collision stuff, it's just not, the normals are flipping back and forth. So as you can see on this face, we're going between positive and negative. And it would be really easy to say, oh, just swap it based on the position of the object, but that defies the whole fucking point of having a, collision solver. So I think it's has to do with my face winding for the simplex that I'm giving EPA, but I don't know how to fix that because it's really fucking complicated. So that's where I'm at. That is where I'm at. I'm not sure. I also had this logic for fixing the winding of the points occasionally, but I don't know. It doesn't really seem to see, like right now it's pushing us inward. And then it briefly goes the correct direction. I could try dotting the centroid here again and then no. But our GJK collision is correct. It's simply just the winding of the points that's not correct. It's either the winding or something. I don't know. Yeah, I don't think it's GJK. I think it's actually just EPA somehow. Somehow. Well, I don't know. I kind of want to take a break, take a rest. It's been many hours. Be back. Be back soon. Yeah, I have no clue what it. Like, it's completely a mystery to me why. Why it would be swapping. Yeah. Yeah, it's so strange that the normal would flip because maybe not. Maybe you do need to manually correct it because there's no guarantee. I think maybe I'm not visualizing the Minkowski sum enough, but I don't think that there's any guarantee of the orientation after we create the polytope. But maybe I'm stupid. I don't know. Like, I've tried orientating it to the centroid, and that doesn't seem to be working. Huh. Doing what everything tells me to do, which is if the dist is less than 0 to negate both that and the normal. But is it guaranteed that the normal needs to swap if that's the case? Can I just try to do it like this? Is that stupid? Just base the normal orientation on something different than the... Yeah, this is very wrong. That's very wrong. I don't want to print it out every frame anymore. Yeah, this is very, very wrong. Oh, it's very wrong right now. What the fuck did I change? I changed the winding of those points. Yeah, this is actually like, you know, attempted to be better at least. Back to what I was doing. The reason why I think that we're like freaking out like that when we hit it is I think that it decides that, you know, it just pushes us inside the face, and then it's like, oh shit, we're inside the face, and then it keeps on pushing us further into and then outside of the face because it doesn't know any better. Yeah, this is fucked. I wonder where the centroid is. Well, I don't need a wonder because I can just print it out. Just to know if it's something fucking stupid. Yeah, I think basing it based on the normal is actually fucking stupid because it's supposed to be based on the origin, not the normal. So I wonder if there's a way for us to know, to figure out based on when the sign flips if there's something going on there. If something's different on that, on those iterations. It doesn't seem to be based on how many points we have. If it doesn't seem to be based on how many points that we have, then what could it be that causes this face to be different? Maybe it's an expand hull. Maybe it's always this secondary face. Maybe it's never a face. Only very rarely is it the first face. Actually, hold on a second. I see a pattern. One centroid goes positive. One centroid goes positive, stays positive, stays positive, stays positive. One centroid goes positive, stays positive. Okay. Why would it persist? Why would it persist? Why would it persist? Because then it goes back to two centroids. What would persist? One centroid means that the face is on it, is on the simplex. But then this means that it isn't on the simplex, no? Huh. So maybe my winding is fucked. Uh-huh. I'm just gonna try fucking with the... Is it the same pattern, or... No, it's not the same pattern. Fuck. I wonder if inside expand hull, when I add horizon face to hull faces, if there's no guarantee about the orientation. We just use PE. Oh, fuck. Oh, fuck. Hold on a second. I auto-correct faces to the centroid. Was that it? I think that might have been it. Maybe not. We're printing out a lot of stuff. I think that that's probably where it is, though. Instead of center to A, how I should be doing it is just based on center. It should just be the dot of this to the center. Oh, fuck. Opposite way. Okay, I don't know what I'm doing. I have literally no clue what I'm doing. Now let's stop printing out centroid and instead print out the normals. So the reason I had that was because of when generating the holes, it's the same code. And so I was flipping based on... we still are getting some. We still are getting some. It's definitely not as bad as it was, though. I'm going back to the windings that we had before. Oh, fuck. Oh, fuck. What is the correct winding? I should have more examples that say what winding we had. It is... fuck. Yeah. So I did BDC, ABC, BDC, DIC, ABD. BDC. I think I need to change. Okay, never mind. The winding was exactly the same. Fuck. Okay, well now it might be the winding of the other points. Now it might be. Now it might be. I don't even have the code that preserves the winding that isn't what I already have, what I'm already checking here. So I'd have to get it. It happens specifically when we're near a edge now. Seems like we fall through the cracks. Right, his example code said that we should change that winding, but yeah, I think that's pretty much all I can do today. You know, like, yeah, let's preserve the winding that they use here. So they use ACD ADB. ACD ADB. Which leaves us with DAC, or AC, what is it? It's DBD, or CBD. Yeah, once I tried their fucking winding, it goes horribly wrong. But this just proves that it's an issue with the winding. It might be something where I may just need a like, if like, take the centroid and then just check the normals. So fuck, that's actually kind of a pain in the ass. So check this. ABC and the normal, we don't even use the face normals. Or at least I don't think so. but we might as well do this. Instead of swapping them later, let's swap the normals early. That's what I'm thinking. And then we just follow the same pattern down. Yeah, maybe dotting the centroid against the normal means nothing. Yeah, maybe, yeah. Yeah, maybe that means nothing, I guess. There has to be a way of doing this, though. It's definitely not less than 0. That's for sure. Since we're working on the Minkowski sum, it should probably just like be the, since we're going origin, it should probably not have anything to do with this, and it should probably be dot the normal with like that. Yeah, and then it gets all fucking discombobulated. Yeah, the winding really does matter. If the winding is fucked up, then the whole thing's fucked up. See, it's like it rarely goes through. Alright, I'm out of here, I think. I really wanted to get it perfect today, but don't think that I can do it. Don't think I have it in me, unfortunately. Don't think I do. I wonder if the centroid is used anywhere in here. It might still have to do with the add horizon face to whole faces, actually. Might still have to do with this. Because at the end of the day, our winding is arbitrary. I could have a boolean for if it's incremental whole gen. I don't know, just holy fucking shit. That's funny. Yeah, that broke everything. Me doing it with the other winding. Yeah. Yeah. This is what it used to be. And then we would swap the two. But this leads to the same issues that we had before. Who knows? Maybe the winding that we're looking for is dependent on us doing this here, but not for the incremental hole stuff. Maybe I need to keep it separate or something. That might be the case. All right, I'm piecing out. I don't know how to switch the normals without just like kind of just like hard coding. Hey, if it's not away from the center, then don't push it. But you know, I don't want to do that. But I'm probably just missing something stupid. It may be that me using this expand hole from the incremental hole gen, I may have to change it for this. There may be something that I'm missing when it comes to the support points, etc. It seems like it basically just adds one support point and then exits out pretty much immediately. And so whatever min it gets, yeah, not sure. Also, there's no guarantee that the simplex that we get in has the correct winding, because by the time it gets here it could have gone through a number of transforms. So I don't know. This was fun. I got a lot done, so there's nothing to be mad about. You know, I got GJK working, and it wasn't that bad. But the EPA stuff still needs work, I think. So, all right, peace out.